presentation day for the Masters of Advanced Studies for Architecture-Based Enterprise Engineering Leadership Program. Excited to have 7 teams will be presenting today. So some administrative procedures. By the end of Sunday, August 28th, your final project reports and final presentations need to be submitted. Professor Sorensen and I will read each of the project reports, and we'll also have additional faculty members review portions at least of some of these as well. So I don't know any faculty members who are present if you want to do a quick call out to the students.
Well,
Alexander Zak is here.
Thank you, Alexander.
And Ingolf's here.
And Ingolf?
Yes. Hello, everybody.
Okay.
Good luck for your presentations.
Thank you, Ingolf. And Wendelin is here.
Hello, good luck, everyone. I'm really excited to see what you've come up with.
And we have Amelia here as well, who I don't know if you've met Amelia, but she's an amazing part of this program who helps us greatly with evaluating your work and providing feedback. So many thanks to Amelia. So all the materials that are going to be submitted, the executive summary, final presentation, and the team project reports are going to be available, as were the ones prior that you were able to access. And I believe we're going to be recording today. Is that correct, Stacy?
Yep, we're live.
Excellent, fantastic. So a program evaluation, there's going to be a formal program evaluation form that you're going to receive probably on Sunday. Also later in the fall, you'll receive a really in-depth program evaluation that we're going to be using to help shape future of the AESE program and some of the expansion specializations that we're putting together. So that'll be quite helpful. And I'll be meeting with each of the teams after you've gotten your final project reports back and graded for any feedback that you might have on that. So you may have completed all your work, but we're certainly not going away anytime soon. So with that, we've got a very busy schedule. There are 7 projects that are going to be presented. Each one of these, we have 45-minute slot. So 30 minutes to presentation, and I'll be the timekeeper. So please do keep within your 30 minutes, and then we'll have 15 minutes where we'll have feedback. Hopefully from some of the people that are visiting and attending this from your different companies, friends and family, and so on and so forth. So certainly we'll give them the first chance to ask questions, and then anyone else who'd like to ask questions as well. We have 15 minutes for that. And then there's a brief 15-minute break between the groups so that you can set up and everybody can sort of be ready to take it from there. So it's going to be the Killer Eagle system starting out, SYMBIOTE, the C4I protectiveness readiness presentation, and then lunch at noon, and we'll be away for an hour, and then the wildfire suppression experience reactivation system, Gatekeepers, Visium, the digital engineering factory, and then we'll have a few closing remarks, and hopefully we will be concluding promptly at 5 p.m. Pacific time. So with that, I welcome everybody. It's a great honor to be here, and we look forward to seeing what your teams have put together. I know that you've all been working hard this entire past year, and certainly over the past 4 days. So with that, we'll kick it off to the Killer Eagle system.
Hi, good morning, everyone. Welcome to the first presentation of the day. My name is Star, and I, along with Christian, Devin, Tad, and Nathan, all from Northrop Grumman, are excited to present to you the concept for our Killer Eagle system, which we've spent the last year developing. Next slide. So the real world problem that our system is addressing is that terrorists are weaponizing small unmanned aerial systems with improvised explosive devices. Terrorists are then using these weapons to target and kill military forces and civilians. These weapons are essentially considered a poor man's weapon, as they can easily be procured anywhere from Costco to Amazon and weaponized for under $1,000. These IED drones are considered effective as they can obtain direct access to perimeters, protected areas, and zones of difficult access by land, with the ability to bypass conventional security measures. Next slide. Now I would like to present to you a short video on how ISIS has evolved in their use of these drones since 2014.
ISIS has an air force, and it's made up of consumer drones. ISIS has been using drones since 2014, at least. Initially, they were used for surveillance and making propaganda videos. They were also used to direct mortar or rocket attacks. Eventually, ISIS started using drones as a sort of do-it-yourself air force. They became especially prominent in Mosul as ISIS lost more and more of the city. When they weren't dropping homemade explosives from the drones, they were using them to direct suicide bombers to their targets in the urban terrain. Mainly with
As you can see from this video, the use of consumer drones is aiding this terrorist organization in the killing of civilians and military forces by surveillance, suicide bombing, and explosive devices. If you move your attention to the graph on the bottom left of this slide, you will see a depiction of the number of casualties recorded from these killer drones in a 10-year period. These weaponized consumer drones are responsible for well over 100,000 deaths in the reference timeframe. While these deaths have occurred outside of the United States, a recent Newsweek article suggests that they're a real threat to Homeland Security, even going as far as claiming as they could be responsible for another 9/11 type attack. Just imagine how a crowded stadium or any major event with large gatherers can be an ideal target for these weapons without effective countermeasures. Not only are these killer drones a threat to lives, but they're a threat to our global economy. In 2019, they were used to attack a Saudi oil facility, and in a matter of minutes, these drones were able to reduce global oil production by 5%. Due to this emerging threat, the Secretary of the Army established a Joint Counter Small Unmanned Aircraft Systems Office in February of 2020. Out of that office, a request for information was released to solicit from industry new technological solutions to address our current capability gaps, which Christian will discuss with you on the next slide. Thank you.
Hi, good morning, everybody. My name is Christian Chapman. I'd like to talk about the missing link and why this emergent threat is so successful. So if we think about a traditional ground-based radar system, they're attuned for more of a long-range search of traditional assets. I want you to think of like a fighter jet, which flies much higher, is bigger, faster, and has a different propulsion system. This leads to differences in radar cross-section, propulsion heat signature, and threat profiles of known existing enemy assets. I want you to compare this to small commercial unmanned aircraft, which are utilizing battery propulsion. They're quiet and flying low and slow. Got a couple of figures here that I'd like to draw your attention to. In the top right, we have a radar sweep. And then in the bottom left, it shows how an obstruction of a hill or tree creates a dead zone for these low, slow flyers. So not only do we have a detection issue, we have an issue of identifying these UAS threats. So once it has been detected, it's hard to identify it. And this is caused by the lack of an IFF transponder and some of those other differences I was pointing out between traditional assets. So this leaves the forward operators effectively on an island. They're time constrained to identify and left uncertain as to where and what this target is and whether it is a threat. Finally, we have a gap in our weapons engagement plan. These forward operators lack long-range support due to endangering fragging friendlies. I want you to think of like a top-down firing situation. And then the rapid reaction response teams are left using small arms, which lack the munition and accuracy required to effectively engage these targets. So in developing the Killer Eagle system, our use cases were developed while identifying these capability gaps. So that'll bring us to our next slide, please. All right, so what's the solution? It's the Killer Eagle system. Key's vision is to provide a highly mobile and effective area of protection against small UAS IED threats in forward operating bases, and to protect the lives and property of those within its reach, to supply operation commanders with the tools necessary to meet and defeat the enemy when time is of the essence. So the enabling factors for Keys to have an effective kill chain is its primary use case, which is those gaps we identified, the ability to detect, identify, and engage these hostile UAS threats. So Keys will integrate existing Northrop Grumman assets to advance the counter-UAS capability, namely our detection sensor, which is the ANTPS-80 Gator. And I'm going to hit you guys with a couple of acronyms here, so please bear with me. So Gator stands for the Ground-to-Air Task-Oriented Radar, which is a mobile unit, offers three-dimensional multi-mode gallium nitride active electronically scanned array. This provides 360 coverage to the designated friendly airspace. Next, our identification system is dubbed the Falconer. This is Key's artificial intelligence machine learning module. Falconer will be responsible for integrating Key's weapons, sensors, and operators to provide identification and fire control solutions. It does this by ingesting all variables of interest throughout an engagement and compares against known threat libraries to provide a supervised machine learning analysis to what is new and what is known. This database will grow as the frequency of engagements increases and enables the Keys network to evolve to varying threat types and distribute increasingly accurate identification and fire control solutions throughout all of the Keys fielded systems. And lastly, for the engagement, Keys will provision the Mark 310 programmable airburst munitions type, another development by Northrop Grumman, which supplies airburst, point detonate, and proximity neutralization capabilities against hostile UAS threats. I think it's worth noting that Keys is tailoring this kill chain towards group 1 and 2 UAS drones, and these drone categories are incrementally grouped according to their max takeoff weight, maximum altitude, and maximum speed. The group 2 upper limits are 55-pound takeoff weight, 3,500 AGL, and a maximum speed of less than 250 knots. And these are the characteristics that are most aligned with the commercially available products that we're seeing. While larger US groups can be a capability option for growth for Keys in the future, it's a little outside the scope of this emergent small US threat type. So 3 links and kill chain contributed Keys' ability to provide a mobile modular counter US defense and drive its measures of performance, which is time to identify, accuracy of engagement, and reliability of the sensors it's using. So these performance measures will drive Keys' measurement of effectiveness. And I'd like to bring it on to the next slide, and Devin, who's going to go over our OV1 and operational concept.
Thank you, Christian. Okay, so this is the perfect roll into what is the Killer Eagle system. So as you can see here in this OV1 diagram, the Killer Eagle system can be deployed either at a FOB or a base to protect the base itself, or it can be towed and carried along with the convoy or a platoon out into the field. Using the Falconer AI system, it allows the user to set up a mission planned airspace for protection. Once a threat enters this mission planned airspace, then the Falconer AI system will then engage, identify and alert the operator, and then the operator has the choice to either engage or not engage the threat. The Falconer AI also has an option to autonomously engage the threat as well, and I'll go into that a little bit later. But first, I wanted to go over the overview of the system. It uses a tactical data link to really have threat data dissemination to other systems that are currently on the link. It will send out the number of targets, this method of detection, the method of elimination of that particular target, and it will share that data, and it will use machine learning to really learn and also apply those tactics to the rest of the system, so that way all operators on the network can understand what's happening in the battlefield right at that moment. The data is also stored and processed via cloud data storage and processing, as well as again, disseminating that data through the network to all the users that are in the battlefield. There are many different detection methods. You can use IFR, IFF, radar, spectral imaging with change detection, or you can use signal intelligence. And then for our elimination methods, there are a various amount of different methods that you can use for rapid fire munitions, electronic warfare jamming, airburst rounds, as Christian mentioned, or GPS jamming. Next chart. Oh, in fact, can you go back one chart, Tad? Got to mention one thing. The great thing about keys as well is that even if you're using it at a base and you have multiple systems set up to surround that base for protection, the Falconer AI system can be operated by a single operator operating multiple systems at the same time. So you don't need to have multiple operators operating, say, 3 or 4 different key systems that are set up at the 4 corners of a base. It can all be controlled by a single point and a single operator to be able to provide that force protection at the base. Next chart, please. So here are the features that I kind of touched on a little bit. The Falconer AI suite, as I mentioned, it's a mission planning suite for the operator. The system has autonomous detection, and it has an automatic or manual fire control. Now, this fire control can be set in different user profiles depending on the environment that the user is actually in. If you're in an urban environment, you may not want the system just popping off and firing at drones in the air due to civilian casualties or collateral damage. So you'll have a level of operator interaction before you engage. Another profile would be convoy control. So the system is now on the move. It's either being towed behind a Humvee or a trailer or a truck, or it's actually driving itself autonomously behind the convoy and is providing protection to a certain level that the operator can set, whether it's autonomous or manual intervention. And then the third level is a high threat control profile, of which the system is purely autonomous. The operators are in a highly endangered area with high threat, and therefore they're going to be busy executing their mission, and they need the system to autonomously protect them from these low-flying IED threat drones. With the mobile platform itself, again, as I mentioned, it's towable by a trailer, or it has autonomous capabilities. It's a battery-operated vehicle that you can set a mission plan to, and it can actually provide autonomous protection on its own. The system is modular and very customizable and mission tailorable to whatever the mission needs are. And I'll talk about that a little bit later. And again, this system also has its own power source to be able to provide power for all the systems on board. The detection options are also modular, so the customer has the advantage of picking and choosing which particular types of imaging it wants to use, electronic warfare, any type of radar sensing, or can even deploy its own hunter drone that can go out and kind of extend the detection further away from the actual base of the vehicle itself. And then you also have modular threat elimination options as well. Again, options are EW jamming, RF jamming. You can choose from variable weapons and munitions. And then also, as Christian mentioned earlier, the gap that is seen is if you're trying to fire upon threats from a far distance from a FOB and trying to protect the convoy, you risk a lot of friendly damage. So this provides the advantage of basically ground up firing. So therefore, you're not putting any of your local troops in danger. Next chart. Now, I spoke about the modular capability solutions, and this is exactly what I'm talking about. In the center there in the blue box, you can see the baseline platform for the Killer Eagle system. You're going to get the Class N ATM battery electric vehicle / trailer that comes with its own power supply and 190 horsepower electric motor, and is completely autonomous when needed, or it can be towed behind the trailer or behind a Humvee in the convoy. The heart of it all is the Falconer AI suite, which uses Kite Strike rugged AI processors. This will house all the mission planning suite, as well as the threat engagement suite and the tactical data links, and provide really the hub and for the Killer Eagle system. The operator station is a GTAC ruggedized laptop with multi-screen. This can be packed up and moved anywhere, so the operator can operate this while sitting in the Humvee in front of the towable trailer, or it can be sitting in a tent somewhere and operating the trailer autonomously from a distance. And then your baseline satellite link or tactical data link would be Iridium, but you have options as well to choose other data links. Now, if you move to the left box, these are your modular detection solutions that the user can define and select depending on the mission. So you have your spectral imagers. You can use the millimeter wave radar with drone tracker, your Eagle Hunter Sentinel G3 drone, as well as an IFF system. And then you've got your ELIN antenna that can do some EW and RF tuning. Then on the far right box, you have your modular kill solutions, so the user can select, or the customer can select to equip either a minigun or a cannon or whichever it prefers. For munitions, we are preferring that you use the medium caliber ammunition provided by Northrop Grumman, which provides air burst for a good proximity elimination kill of the drones, and it can also be guided. There are also other munitions options that you can choose as well. And then in the bottom, as the EW and GPS jammer with antenna unit. Now, again, as I mentioned, the center is your baseline platform that you would get, and everything else is an add-on depending on your mission, so you can make it mission tailorable. Now, to talk about the keys benefits, Tad will continue that on the next chart.
Thank you, Devin. My name is Tadios. Let's talk about benefit. KES has multiple benefits, but we chose top 5 benefits to talk about today. The first one is cost effectiveness. By using real-time data, provide information. If one system identify a new threat, the next location will rapidly learn about this new threat. We'll be also using existing NG weapon system. The second benefit is accelerated operating learning. Using the Falcon AI system, the system will be rapidly learning, getting multiple input through IFF, radar, infrared, image processing, and signal processing, as Devin mentioned. The system also auto-identification. To ramp up the learning process, we'll be using DoD profiling library. The next benefit is user-friendly, and it's easy to use. Since great user experience is resulting fewer operating error, we'll be designing our operation. We'll be considering operator action in mind when we are designing this effort. This means modular design allow great flexibility in deployment. Speaking of deployment, the next benefit is rapid deployment. We'll talk about the roadmap in the next slide, but KES is quick to set up and quick to tear down if relocation required. Imagine this system is a security that travel with you. The final benefit is sustainment. We'll be providing 24/7 round-the-clock protection. The system will be also tolerable, equipped for various mission type. When we go to the next slide, we'll talk about the roadmap. When we look at the roadmap, we have 4 major timeline and 2 optional. The first 2 years will be rapidly prototyping and fielding. That means accelerating the KES profile and the Falcon AI start learning. The next 3 to 7 years will be core production. That means scaling up the production and manufacturing, increasing the strategic value of KES system. When we look at 5 to 12 years, we'll be working on continuous modernization, which means integrating multiple sensor and applying it into different platform. And then finally, between 8 to 15 years, will be platform operating and sustainment. That means we are growing and essential system effectiveness. So on the bottom, we're looking at the different option. We have 2 options, which is a strategy looking into the different market, which means foreign military sales, also looking into the swarm target, there are different strategy, which the KES, the Falcon AI, now it's learning a lot. That means we be able to address into different platform and different level. Without further ado, I'll pass it to Nate regarding the finance.
Good morning, everyone. I'm Nathan Chafee. I'll be talking about the program financials, market outlook, and growth opportunities. So the core KES platform accounts for the majority of the program revenue. We're estimating a 15-year program life cycle from inception to eventual DoD divestiture, over which we're expecting a cumulative return of about $638 million, not accounting for discounting. Will drive our net present value down to around $386 million. That does require an upfront CapEx investment. We estimate around $127 million. This will account for program space, the buildings to operate, secure systems, IT systems, SCIFs, and laboratory equipment. And we expect multiple revenue streams from the core platform. That would include the sale of the platform itself. It would include maintenance and upkeep of the Falconer AI system, evolving and training that system, as well as the operational and sustainment revenue generated from maintaining the capabilities in later years, program refresh, and any modernizations. Modernizations are an option. We estimated that option to expire approximately year 4, after which if the DoD is going to exercise, they're probably going to by that point in time. Modernizations would include payload and sensor upgrades to integrate into the system. Lessons learned from the field. If we field the minimum viable product and we learn that, well, maybe we need a different radar system, maybe a different payload engagement, we have the option to do so. That would require a small CapEx investment, mostly for the test stations and laboratory space to facilitate that integration. We expect, if executed, we'd return probably about $194 million, the net present value of 44.7. In a real option analysis, we're coming up with 89.1 million. In the roadmap, we also talked about the optionality for swarm modes. We believe that this is a very critical option to address for reasons that we'll get into in the next slide. We estimate that option expiring in approximately year 6, requiring a smaller CapEx investment. There is less capital equipment involved with this. It's more of a space and programming software effort. Total return on that, we're expecting to be $82 million. So while essential from a capability perspective, it does produce a little bit less revenue. Another option we have is new market pursuits. So this is looking at the global perspective of counter UAS solutions, as well as domestic opportunities, both in private and civil government. Our core customer we're anticipating to be the U.S. Department of Defense. However, there are ample opportunities emerging with the Department of Transportation. It comes to airport security, the FAA in that case, the Department of Justice and Bureau of Prisons is another opportunity. And then likewise, looking into the foreign markets, pretty much every major U.S. ally, including NATO, is looking at counter UAS solutions. A couple critical technology areas for the success of this growth story, for not just keys, but any market entrant, is going to be our ability to produce data fusion. This is where Falconer AI comes in to merge and learn from the data that we collect from the battlefield, evolve itself, and rapidly expand its capabilities to encounter emergent threats. Detection fidelity is another technology area that the market is focusing on. This is the ability to discern friend from foe and also friend from non-combatant, whether that be something as simple as a bird passing by. The system's ability to make those determinations and do so quickly and feedback to the operator is essential to this growth story. Lastly, we have payload integration. The market is, while we talked about the kinetic solution in the airburst round, the market is forward-looking and projecting a need for directed energy payloads, as well as soft kill methods, particularly in civil spaces where destructive engagement solutions are suboptimal. If we can go to the next slide, please. So this is a very forward-looking perspective on the growth opportunities and market as we work our way through the decade. I'm going to start on the right side in the upper quadrant and talk about kind of the theaters that we're seeing today. So the theaters themselves are quite varied. In the past 10 to 15 years or so, we've seen the prevalent mode has really been non-state actors, low-tech improvisation of platforms. So as Star kind of brought up in the lead-in, these are your, let's go to Walmart and duct tape a bomb on it and fly it into something. The strategy in this is mostly disruption and destabilization. Primarily in a terroristic content to produce fear and disruption in the populace. What we're seeing emerge today in the Ukraine theater is very interesting, as we're seeing kind of a shift away, but not a total shift away from this past paradigm. We're still seeing a large amount of improvised platforms, if you will, but they're state sponsored. They are of a much higher caliber and technical degree. They are precise, they are loitering, and they're able to strike at pressure points. So rather than going to the effect of mass casualty, what we're witnessing is the employment of drones in not just in a tactically capable, but strategically relevant sense. The logic there being, instead of simply attacking, boots on the ground, if you hit their supply chains, if you hit their command structure, you're able to force multiply that platform to a much higher degree of effect. So we're seeing the evolution today. We are currently in the inflection point of counter UAS or of UAS, and by proxy counter UAS to meet those emergent strategies and demands. As we look forward into the next decade, the DoD in general is very interested in tackling our near-peer competitors. In the context of UAS and counter UAS, this means that our threats are most likely to be evasive, informed, and coordinated. They're going to seek to evade and overwhelm our defenses. So the ability to detect evasive threats, stealth threats, or engage an overwhelming swarm of platforms is extremely relevant. From a global market perspective, we're estimating from 6.5 to 11 billion annual investment on a global scale between now and 2030, a CAGR of about 15 to 25%. Regional numbers are given there as well. I think we're good here. I'm going to pass it back over to Christian to wrap us up, and thank you.
Thanks, Nathan. All right, so in summary, so the need for a counter UAS capability is crucial and imperative. It's entirely way too many people being killed by air-launched improvised explosives. All the while, these SUASs or small UASs are becoming more commercially available, have a declining price trend, and are continually improving their technological capabilities. I think Nathan pointed to Ukraine, where you can see this asymmetrical warfare currently at play. So as solution, Keys will provide an integrated mobile and modular defense system by supplying the detect, identify, engagement, kill chain capabilities necessary to thwart UAS threats in forward operating areas and protect the lives and property of those under its gaze. Business case for Keys, it'll be a unique market differentiator in a quickly growing global counter UAS market and offers a positive net present value of roughly 589 million and a real option value a little over $1 billion, inclusive of the capability upgrades and expanded markets outside of military application. So what are the next steps? We need to secure the funding required to proceed with rapid development and prototyping, complete preliminary design evaluations, and perform capability test demonstrations to deliver and field initial core platform capabilities as quickly as possible to Special Operations Command. This will drive early value creation necessary to integrate design performance prior to low and full rate productions. So with that, I'd like to say thank you to everybody for taking the time to listen to our presentation and open it up for questions.
Thank you, team. Within 1 minute and 20 seconds, so great job. I'd like to open this up to everyone online to put your questions out there. So feel free to unmute and ask a question. Professor Romer?
Yes, good morning, everyone. It's good to see you. Thank you for working on this. This seems to be incredibly important. You started out with talking about the threat to civilian populations. On your last slide, you talk about attacking, working on military attacks. Then in the business case, you talk about civilian space again. Most of your slides show battle scenes. I can see shooting stuff down on battle scenes will work. In civilian spaces, I'm a little worried. Yet I would think that protecting the civilian space would attract larger amounts of money. Is there a danger that you are designing something that is being superseded by something that is protecting the civilian space and the military space? What are your thoughts on that?
So initially, what piqued our interest in this concept was the request for information from the Department of Defense. So that's our initial target market. But as we conducted our research, we started realizing how important this is also to the civilian market. So essentially, we'd like to kick it off responding to the Department of Defense. But as we've created the design and made it modular, we have created an opportunity to sort of expand it and adapt it to the market in which it's going to be useful.
Yep, and as Nathan had mentioned as well, in his growth opportunities chart, that's one of the options for the new markets is a soft kill method, something that you would more so rely on, something that's not so kinetic to be worked or to be operated in the civilian theater.
Thank you.
Professor Kruger.
Yeah, thanks again to the team for the presentation. Can you go back to your OV1, please? Yes, so thank you very much. At the very top of this diagram, you have cloud data storage and processing.
Yes, sir.
Are you convinced that this set of technologies exists everywhere where you want to deploy your solution?
Well, I think that's the key to having it be beyond line of sight and using satellite tactical data links is that we can then have a ground base, say at a US-based location or even a European-based location, depending on the theater, of which you would then pipe data into a data processing center that may be composed of virtual machines or Microsoft Azure Stack Hub. And then at that area, you would then be able to implement your processing and then redissemination of the data that's usable by the Falconer AI system in the field.
Okay, So basically the design rests on the fact that all these cloud technologies that you've just mentioned would be available everywhere in the world. Is that correct?
That is true. However, the system is capable, due to its Falconer AI system, to operate if there is a disconnection of the tactical data link. So it can still operate on its own. It does not require commands through the tactical data link. It's only for threat data dissemination.
Okay, thank you.
We have a question online from Kenneth Miller. The question reads, how many simultaneous threats can this system address from a single node? For instance, 8 to 12 incoming drones.
I'll go ahead and take that one. Kenneth, that's an excellent question. The minimum viable product of keys is targeting a kind of single detection, single engagement solution to start out with. The optionality for swarm modes is what we're really talking about here. When we start to get into 2+ engagement solutions simultaneously, there's a number of constraints with that. Number one, there is a software and tracking constraint that would have to be managed through software. And then there is also the engagement constraint, which will obviously depend on the payload solution that you have at the time. So something like a directed energy weapon, will obviously be limited to the spread of that direction of energy. Something like an airburst round, the effective ranges and whatnot of that, I can't really get into. It would be able to engage multiple, provided they are closely grouped. However, it's a reasonable expectation for particularly informed and advanced adversaries to develop swarming measures to counter that. So minimum viable product is 1 engagement. When we get into swarm modes, it really depends. We would like to be able to target that option and that development path to counter, highly sophisticated, large swarms of drones, upwards of, let's say 100. Understand that's quite optimistic. It may require multiple platforms and multiple coordinated key systems, but that is the optimistic outlook. Thank you.
Thank you for that. Have a hand raised from Oscar Guerrero. Oscar?
Thank you. Greeting team. Just following up on Professor Romer, even if you don't use a kinetic countermeasure, right? Let's say electronic warfare, if you're like in a dense urban area, you may be affecting things like the communications of first responders, or if you're near an airport, aircraft they're trying to land or maneuver or things of that nature. I didn't quite see your governance structure or how independent stakeholders that you're going to affect that are near you are going to come into play. Something to think about is maybe bringing in things like AESE for airports or first responders and how they affect your governance model or your rules of engagement for this type of thing. I'll give the example of Israel, right? If they're under a state of attack, their governance structure may change to how willing they are to use electronic warfare versus when it's peacetime and they don't want to affect first responders and things of that nature. So just, what are your thoughts about your governance structure and how you would adapt it depending on your local stakeholders, not just your primary user of this?
Yep, I think you bring up a great point, Oscar, and I think we're also seeing something similar with the ADS-B rollout, and it's infecting the radar altimeters of a lot of commercial airlines operating within terminal airport areas. It is something that we'll have to develop and think about. There could be many different options that you could use. You could introduce notch band filters on the EW systems to try to eliminate transmitting on those emergency frequencies. But it is something that I think going through our development and testing that we would certainly take into account as a requirement to be able to do it through different modes of heightened threat increase, be able to be selectable on which frequency bands we interfere with and which ones we don't.
I guess just a quick follow-up on that. I think there needs to be a mechanism for local stakeholders as well to participate. You know, when we were in Iraq and other areas, not bringing in the locals caused issues at times. So I would caution you, it can't just be technical solution, right? You need to have that other aspect in there as well.
Yes, sir. Agreed.
Thank you for that. Professor Zach.
I'm wondering whether it would be worthwhile to set up a small subgroup focused on a competing system to try to circumvent yours, so that you would be selling both, and you would be able to increase the heat on one by advancing the other. Is that something that you could consider as an option? Would that be an interesting project? Let's say next batch is coming in a month. Would that be an interesting team project that you guys would like to track?
Alexander, do you think maybe you could give a little more amplifying information to that question? Or what is it that you're suggesting?
If there were another team, AESE team, focused on developing technology and approach for how to screw your system over.
I think that would be very beneficial, yes, to have that data on how exploitations of the system work.
Yeah, it may be something that would be interesting for you guys to consider, so that you have, a Chinese firewall and you have your own testing group that is evolving together with that system. And that may be a useful offering for the same clients that are buying your systems.
I think it will be absolutely very helpful, because we kind of gonna be like working together in a sense, like we're defending more effectively, and then that I think the system will be really more effective when there is a opposition party that is pushing against it.
You want to keep people who write the test plan separate from the ones who do testing, but at the same time, it may be worthwhile to invest in both at the same time.
Absolutely.
So
I was
there's
going to
one.
jump in.
Okay.
Oh, sorry, I can't raise my hand for some reason. But this is Keith Archibald. I'm an old student about 100 years ago. It's great to see all these great faces from the old days. But I think Alexander's idea was excellent, red teaming the system. But what I wanted to offer up was, I work in this area, this space quite a bit. And I kind of do venture capital for the government now, and trying to find them the best solutions, and using public and private capital. Would you guys be interested in presenting at another forum? We have one, it's called the Disruptive Technology Lab at one of our labs. And I'm also working with Army Special Forces, which would also be interested in pieces of this, I think. So if you're interested in a follow-on meeting or presentation, let me know and I can set it up.
Absolutely, Chief. That would be fantastic.
Thank you.
Okay. I've got like 2 more questions here, but I'm going to raise one that was given by Melanie Haggerty. And the question reads, very interesting presentation. Thank you. If the KES team is detected by enemy and is ambushed and has to leave the trailer, can the AI suite be compromised? Especially if a single suite controls multiple base protection systems. How vulnerable is a system when it's on the move?
So I can address that. So the governance structure that we'd be using for cybersecurity would fall under current STANEG and STIG implementations, and the vulnerability of could the AI suite be compromised? I think the answer is yes, anything's possible. And I don't think that's a unique situation to any other time military forces are engaged, right? You kind of left with the problem, leave it there. You can blow it up before you leave, or yeah, destruction team. But as far as cybersecurity and network implementations, yes, we have considered that and would like to align with those guidances.
Thank you. Got one late breaking question. We're at 45 minutes, but I'll try to tuck it in. From Andrew Rahardo Sai. Question is, when did the five porter forces, did the KES include Anduril lattice as threat of entry or substitute? I'm not quite sure I understand the question, but maybe the team does.
So I'll take that, and Star, you can back me up because I think you were kind of the lead on the Porter's five forces. So you're referring to Anduril, who I believe is one of the it's one of the market entrants, and in our research, I think we found that they have quite a large portion of the market share right now. I don't know that they're quite as much of a new entry as they are a current competitor. I do think that, we took into account, the present market saturation, some of the platforms that are out there, and, what can we do differently, right? I think the addition of an AI component, stressing, tying data together, tying systems together, making it less of a single point, single node and standalone platform and more of an integrated solution is kind of one of our responses to the field that's currently out there. Sorry, would you have anything to add to that from the analysis itself?
No, I think threat of additional entry is a valid concern. There's probably going to be, multiple companies going after this work. I think the fact that we are able to bring in Northrop Grumman solutions that are already developed, reducing non-reoccurring engineering costs, we're able to bring this to market at a best value, lower rate. So I think our cost into the market is going to be very attractive to those buyers.
So I'm going to have to end the questions at this point, but I really thank everyone who asked such thoughtful questions, and a congratulations to the team for a job well done. Congratulations to all of you. And we will start the next presentation in approximately 12 minutes. Thank you.
Thank you.
All right. Thank you, everyone. Good morning. We are Team Cubic. I'm Tony Hildebrand, and here at Cubic in San Diego, we have Boris Fratkin, Dan Haynes, Jason Weldon, and Rick Kent. And coming from the East Coast is Noah De La Hunt. We chose to try to be as much in person as we can, so we're all in the same room here. You'll see us coming in and out of the screen. If you could, go ahead and pin Boris's window to your screen if you'd like to see the speaker. So thanks for attending our capstone presentation, and a special thanks to our stakeholders joining us from Cubic. So let's get right into it. So Cubic today is a siloed organization, and there's an opportunity to connect the different parts of the enterprise for greater efficiency. Overall, the business units at Cubic do not share resources as well as they could, and operational efficiency could be improved by following good practices and procedures. Additionally, many processes would benefit from AI because they're all performed manually today. So due to the different parts of the business using their own suppliers, Cubic has too many suppliers. This has led to high supplier spending because larger quantity buys are not being executed. Supply chain issues are magnified due to the lack of supplier loyalty and engagement. And it's difficult or impossible to search for some parts in excess inventory for lack of data on some of these parts. We have a long lead time to market. Long lead times on parts exist because of the large number of suppliers we use and the globally impacted supply chain. Estimate at completion, or EAC growth, is occurring at Cubic. This is because lack of operational rigor during the bidding process, and also just some inaccurate historical data exists today, and we need to get better data on projects. So our solution is SYMBIOTE. We want to create microservices to share resources, including parts, labor, suppliers, and historical data for bidding. SYMBIOTE is a phased development with parts sharing and supplier matching first, the easier microservices, then the more complicated microservices, labor sharing, and AI enhanced bids. And finally, at the end, IP sharing. Our goal is to develop the code in-house, but if there are tools that already perform these functions, that'll be considered. SYMBIOTE is an architecture that is loosely coupled for ease of integration of legacy parts of the business and allows for feature expansion. And SYMBIOTE will collect new data and enrich existing data with AI and use the data to search for parts and labor and use it for AI-enabled bids. Moving on to the financial benefit to Cubic, analysis shows that SYMBIOTE has a net present value of over 850 million over a period of 6 years, including perpetuity. The cost for development is estimated at just shy of 18 million, and the SYMBIOTE benefit to Cubic is maximized with the immediate development due to the utilization of excess parts inventory for funding. The next steps are identification of phase 1 funding for development and tests, analyzing the excess inventory, and identifying current assets sitting. We need to improve the data on current suppliers to add markers for improved lead times and reliability. And we need to organize past project data for use in future bids. We need to identify the labor resources needed to build SYMBIOTE microservices. So Noah's going to go ahead and talk about some of the thoughts from our stakeholders.
Thanks, Tony. So to begin our project, we had some stakeholder discussions with leaders throughout Cubic, and we've continued to have those discussions in addition to receiving information through town halls and company announcements. And we've identified the following problems as some of the major challenges that Cubic faces today. And some of these are things that Tony alluded to previously, but we have a low amount per supplier spent due to a wide pool of suppliers that has amassed as Cubic has grown through numerous acquisitions. We've been experiencing EAC growth of tens of millions, and that's something that can make it difficult to reinvest back in the company. So other improvement efforts may not be funded as a result. We have excess parts inventory. These are parts in the inventory system with no demand. And if we can utilize those, it'll turn to profit for Cubic, especially with the lead time issues and supply chain crisis we have today. Some good news, customers are loving our product. We have a large backlog of orders at some of our businesses, but we're not always able to capture that as revenue as quickly as we'd like due to those lead time issues. We're also experiencing high attrition rates similar to other large government contracting agencies, around 20%. This can affect things like project execution, create issues of tribal knowledge and handoff, etc. Next, Boris is going to describe the defense side of our company and its different silos.
Hi, everybody. Thank you, Noah. We value our stakeholders' inputs, and to put their thoughts into a visual context, I'd like to talk about what CMPS is, how it looks today, and where we think the problem originates. CMPS is comprised of 6 different business units you see outlined here on the right. Each unit works independently to achieve their business goal that is integrated into an overarching common goal for CMPS as a whole. But as you can see in this graphic, businesses across CMPS are siloed and have difficulty sharing information or resources. Sometimes functional teams within the 6 different business units themselves are also largely siloed. One back, please. Sorry. Yes, thank you. But as you can see in this graphic, like I said, businesses are siloed. Appropriate information does not flow back and forth between the teams, resulting in inefficiency and uninformed decision-making. Businesses are not in the habit of sharing design information, resulting in duplication of efforts, developing hardware, software, and additional procurement overhead. Working within siloed teams over the years, the company had grown bigger. Business units have been concentrating on growth through acquisition of other smaller sized companies and embedding them into the current business structure. But growth by acquisition comes at a price. Like I've mentioned before, Cubic achieved growth through acquisitions. However, with the recent purchase of Cubic by a private equity firm, the larger focus is on growing EBITDA, increasing efficiency, and pursuing operational excellence. While all of these are good for the potential growth of the company, one must consider the larger implication of siloed businesses units within the organization as a barrier to the goal of the new owners. My teammate Jason will expand on this later. Acquisitions are oftentimes an important step for growing a business. But if acquisitions help solidify the silos, then there is a problem. By creating a system of systems that are poorly integrated to each other, represented here with the red bidirectional arrows, the risk of poor execution increases. Lack of discipline is another risk that may arise. Business units that are siloed may inquire about multiple different vendors to support their design phase. This can lead to an enlarged list of similar vendors that is unnecessary if provided with the same service. We have an opportunity to leverage our scale for efficiency. We want to leverage the scale of 1 cubic to increase revenues, meet our commitments, and deliver a winning client experience. If you are a systems engineer working with the team on a design, imagine a future where you can easily access a database with some valid, up-to-date supplier matrix that can instantaneously help elevate any pressing complex design needs. If you're a mechanical, hardware, or electrical engineer working on a rapid prototype design, imagine a future where a simple-to-use cross-business unit search engine helps find stock parts so that you can quickly implement changes to your existing designs on the fly without having to spend time or effort reordering commercial off-the-shelf parts. Whereas instead, you can tinker with parts that are readily available. I spoke to many engineers across the company, and they all love this idea. Imagine for a second you're a program manager, inquiring information about possible subject matter experts who can help facilitate your project and enable its ultimate success. Just think about the help you can obtain by having a system that can match the skills needed for the project, paired with respective employees' availability. Tremendous. SYMBIOTE can help leverage it. SYMBIOTE can help obtain this. And more importantly, SYMBIOTE can help execute this. Let us move to the proposal solution. The ultimate goal of SYMBIOTE is to increase value. The first objective is to consolidate the number of suppliers used across Cubic to increase spend leverage and reduce costs. SYMBIOTE will gather supplier matrix and learn from executed projects to recommend suppliers from current and future business ventures. If successful, the system will match suppliers to internal clients and meet their schedule, quality, and cost constraints. The second objective is to create a search engine that allows sharing of Cubic stock parts across the corporation. This can help speed prototype production and reduce time to market, utilize unused parts inventory, prevent buying of additional parts, and mitigate global supply chain lead time issues through the scale of Cubic. SYMBIOTE will have a search engine that matches parts based on a set of search parameters and lists Cubic stock of those parts. The search engine will require that Cubic stores more information on parts than is currently recorded in the PLM system that is our product lifecycle management. The third objective is to share Cubic expertise across all businesses and enable a team of teams environment. By sharing employee labor across the businesses, we can shorten development cycles, we can increase quality, we can increase employee utilization and satisfaction, increase the knowledge base of the workforce, reduce the number of job requisitions, and by doing so, save on overhead charging. In addition, SYMBIOTE will match a set of available employees with the required skills and availability based on a ticket filled by requesting party. Project leads will love this. SYMBIOTE notifies each user, obtains any necessary approvals, and automates generation of any required charge numbers. Rick will show you some of the use cases examples next. Thank you.
Thank you, Boris. Our first use case relates to asset sharing across the organization. These shareable assets could include IP, intellectual property, and especially parts. As a design engineer, I may want to easily locate information on designing a specific circuit, training materials, or even a UML pattern. By making information easier to find across the organization, SYMBIOTE will reduce the amount of time spent hunting down information and allow us to easily share IP instead of reinventing the wheel. Our second use case relates to part recommendation. As a design engineer, I want to leverage existing surplus parts that match or are similar to the parts I need in my design. By making parts easy to find and locate, SYMBIOTE offers two primary benefits. First, design engineers will be notified when similar parts already exist as surplus inventory before approaching purchasing. And second, a group buy is able to be made along with another business unit in order to lower per unit cost. Our third use case pertains to supplier matching. As a purchaser, I want to consolidate purchases of similar parts in order to leverage purchasing power and negotiate lower pricing from suppliers. Our fourth use case pertains to labor sharing across the company. As a functional manager, I may be short engineers or need someone with unique or specific skills and might prefer to borrow someone from another organization instead of asking HR to recruit from outside the company. As a functional manager, I also may want to loan out a direct report that isn't currently tasked and that is charging their time to overhead. SYMBIOTE will allow me to access specific data fields within employee records to find someone, a qualified engineer with the skills and availability that matches their tasks. Inaccurate project bids is a frequent cause of cost growth on Cubic contracts. Our fifth and final use case leverages aspects of artificial intelligence to aid in the creation of project bids when bidding on a new project. As someone that does cost estimating, I want to find prior projects with similar tasks and scope to determine the labor mix and cost estimates of a project. Using machine learning, SYMBIOTE will analyze historical projects and supplier performance data to identify similar projects or tasks and recommend an appropriate labor mix and cost estimates. This leads to more accurate bids, reduces estimates at completion or EAC growth, resulting in higher customer satisfaction. Noah is going to talk about how we can ensure the success of SYMBIOTE.
Thanks, Rick. So at the beginning of this project, we want to ask, why would SYMBIOTE fail? It's better to ask that now than later. So here's some of the challenges that we identified in terms of technology, organization, and people for our project. Number one, securing funding. Cubic was recently bought by venture capitalists. They're very sharp people and they want to make a good investment that gives them a good return. We have to convince them we'll make money. Number two, people are naturally resistant to change. They want to do things the way they've always done them. And we've seen this with rollout of other common IT tools. Additionally, everybody's used to working in their siloed businesses. They don't necessarily want to work for another division across Cubic. At this time, the culture is just not set yet. Number three, homegrown code. This can be a challenge. SYMBIOTE's going to need a lot of custom functionality, and homegrown code can often suffer from lack of documentation or original team members leaving. So you suffer issues of tribal knowledge and difficult sustainment. Some of the technological challenges, bad data. So sometimes you can have inadequate part descriptions or project data that's going to make automated predictions difficult. Inaccurate part counts could be another source of volatility and lead to poor part recommendations. External supplier data is not readily available, and we would want to know things like their operating capacity and inventory of parts. Regarding our excess inventory, it has not yet been fully analyzed, and we don't know if all the parts are still usable. We're assuming some of them may not be. For predicting complex project outcomes, this can be difficult. Currently, in terms of evaluating the performance of an employee, we may only have their resume to go off of. And in the same regard for the projects, we don't necessarily have a lot of metrics to go off of at this time. Those would need to be created. So some of our solutions for these problems in terms of funding, once we get off the ground and we can implement the part sharing recommendation system, if we can get teams and projects to target that excess inventory that's just sitting there, it's low hanging fruit, that could make a lot of revenue for Cubic and easily fund the rest of the project. Number two, resistance to change. Governance is going to be key, and we'll need leadership to champion the change down through the chain and get people to buy in. Another thing we can do is offer financial incentives for people to target that excess inventory on their designs. If it's going to make Cubic a lot of money, it makes sense to go ahead and share some of that back with teams. Number three, challenge of homegrown code. We would like to leverage any COTS products to the maximum extent possible. And we've already identified a couple tools that can perform some of the function that we want. For enhancing bad data or bad part descriptions, we can use AI as a starting point for enriching the data using things like text analytics to go through BOMs drawings or a web scraping algorithm, add some searchable parameters to help people target that inventory. When it comes to inaccurate part data, like inventory counts, that's somewhere where we'll probably need some manual intervention and a data team to help us out. For the excess inventory, can we use all the parts? We'll account for obsolete or unusable parts by assuming a certain scrap percentage for the financial analysis. And finally, we'll create new project and team performance metrics, and utilize historical data to the maximum extent possible. Next, Dan's going to talk to us about the business case for SYMBIOTE.
Good morning. SYMBIOTE's impact on Cubic strategy starts with increased profit. Increased profit is achieved through executing within budget using SYMBIOTE's part recommendations and asset sharing. Maximizing the value of what we have is accomplished through higher quality products and on-time delivery. Our on-time delivery is possible because of supplier recommendation based on past performance. Labor sharing also plays a role in that. And last but not least, we will align with Cubic strategy by winning more contracts through AI bidding. Let's move on to phase implementation. Our phase implementation takes about 6 years. I think Tony covered that earlier a little bit. It has 3 phases. In phase 1, we will develop and test required microservices. Some microservices that we will develop in this phase are relational databases, party management, parts matching, and parts resource matching. The benefits of phase 1 are reducing excess inventory and leveraging cost savings to fund phase 2 of implementation. Now in phase 2, years 3 through 5, we will develop a few more microservices, and we're going to validate phase 1 microservice operations. Phase 2 benefits are that we can expand our capability to reduce EAC growth. We also reduce overhead charging with labor sharing service. In phase 3, we will have achieved full SYMBIOTE integration. In this phase, we will be monitoring system function to improve system performance. The benefit of phase 3 is that we're going to increase operational efficiency indefinitely through the use of SYMBIOTE. I'll now turn it over to Jason, and he's going to cover some of our financial aspects in the solution implementation.
Thank you, Dan. SYMBIOTE has a net present value of $850.6 million to perpetuity. The current state of the supply chain has forced companies to sit on the sidelines and watch profits erode, while companies that have learned how to innovate can unlock revenue recognition and grow profits today. Broken into 2 phases to focus on concise implementation, improve SYMBIOTE effectiveness, phase 1 focuses on inventory reduction and optimal part selection for schedule, profit, and requirement needs, unlocking profits today, instead of delaying it up to 2 years in the current state of the supply chain. Phase 1 has an initial funding request of roughly $10.1 million. The net present value to perpetuity is $266.3 million on phase 1, unlocking cash flow from optimal part selection and excess inventory reduction. In phase 2, after we've established the core technology and proven system effectiveness, we focus on program execution with accurate bids and skill set alignment to execution. The investment to continue into phase 2 is $7.8 million. That offers a net present value of $584 million to perpetuity, and combined, the 2 phases offer a net present value of $850.6 million. Now we're going to move on to our solution implementation. Cubic's growth through acquisition has resulted in siloed data systems. Data often exists, but it is difficult to access with no unified way of doing so. Closed off parts databases, software and VHDL libraries, circuit designs, inventory, and employee skill sets that are often available to one part of the organization, but not another, or performed one way in one organization and differently elsewhere. SYMBIOTE leverages the existing infrastructure that we have today and tool set investments while adding new capability that's easy to use. SYMBIOTE deploys into existing business systems and processes that offer web and mobile access to SYMBIOTE from all organizations across the enterprise. Based on our rich service-oriented architecture and Kubernetes to support scalable growth and increase profits, we have load balancing to support additional concurrent users as the system use increases and Cubic continues to grow profits. We offer security, and it's based on a diverse set of microservices to easily incorporate new capabilities and leverage existing interfaces and investments. Now my colleague Noah is going to talk to you more about the measures of performance.
Thank you, Jason. So SYMBIOTE's going to need to collect a lot of different data to support its various functions. For supplier performance, cost, quality, and schedule are the main things we'll look for to determine if a supplier should continue to be recommended. For project performance, a key metric is how the predicted labor mix, cost, and schedule compare to the project actuals. The system needs to learn from this data to tune itself and create better predictions over time. For part matching, we want to recommend parts that are already in inventory with high usage rates across Cubic and lower lead times. For labor sharing, we want to capture overhead charging data to help determine employee utilization rates. Finally, user ratings will be an important feedback mechanism. The system rates its match as a 10, but the user said it was a 1. There's a disconnect that needs to be fixed. Customer is always right, and SYMBIOTE will only be a success if people love using the system. Next, Rick's going to talk to us about measures of effectiveness.
Thank you, Noah. You can also look in our final report for a full list of all of our measures of performance. In addition to these measures of effectiveness for each transaction, we want to call your attention to the 4 that are on the screen. These show measures of effectiveness for SYMBIOTE on an enterprise level. First, SYMBIOTE will track and report EAC growth, estimates of completion, to ensure that it is decreasing over time. Our second, it will monitor quantities of excess inventory, as we've already discussed. And third, SYMBIOTE should foster a reduction in the total number of suppliers while increasing the total spend per supplier. And finally, quarterly revenue should go up. Tony will conclude our brief and take us home.
All right, thanks, Rick. So SYMBIOTE creates a mesh within our enterprise. And Cubic today is a siloed organization that doesn't completely utilize all of its existing infrastructure to the fullest extent because of that way. So Cubic has an opportunity to leverage its scale. It's grown through acquisition. It's become a business with many, many different types of businesses within it. We can leverage a lot of our scale. We can use the different business units to help other business units. So SYMBIOTE can help solve supply chain issues. SYMBIOTE can help improve operational rigor, and execution overall could be improved by SYMBIOTE. SYMBIOTE's a collection of microservices to create a symbiotic relationship throughout the enterprise, and artificial intelligence to find the best way to implement them and use our data. Due to the recouping of parts inventory, it makes sense to execute SYMBIOTE as soon as possible. The net present value shows that development and implementation should take place as soon as we can. We will need to analyze the data and create new data, and also identify the phase 1 funding and resources to implement SYMBIOTE. But SYMBIOTE architecture shows how leveraging scale is achievable and creates value by unifying business silos and greatly improving operational efficiency. So at this time, I'd like to thank you for attending our capstone presentation, and we'd like to go ahead and open up the room for questions.
Thank you, SYMBIOTE team. If you have a question, please raise your hand or type the question into chat. Okay, I see a question from Kenneth Miller.
Hey team, can you hear me? Is that coming through?
Yeah, loud and clear.
All right. Hey, so I definitely wanted to bring up the fact that you guys acknowledged sort of the siloed nature and redundant aspects of how Cubic is structured today. I had a couple follow-up questions for you, and these are kind of, 2 of them are related and 1 of them is kind of separate. So I'll do the first 2 and let you respond to that. And then if we've got time, we'll go into the third. I wanted to bring up how SYMBIOTE is addressing complications that are going to come from the labor shortage and potential fights over subject matter experts. As you said, we've kind of got an attrition problem, right? And we've got, even within our silos, projects that, you know, we are basically stalled on because we can't hire fast enough, right? And that's for a variety of reasons. But that's question number one, right? How does the system decide what's actually important? How does it deal with the egos of the people who are going to be involved in giving the yes or no for their engineers or subject matter experts to move? Second part of that same question is, have you taken into consideration how morale of those subject matter experts might be impacted by having essentially multiple managers, projects, deadlines, sets that are completely unrelated?
So Ken, I'd like to touch on at least one point of your question, which is, I've heard managers talk about before how they are very careful about overhiring. They don't want to hire too many people because they don't want to risk, you know, needing to lay someone off later. Well, with the labor sharing system and the ability to more easily work across divisions, you wouldn't have that concern as much because our collective, you know, workforce can be flexed across multiple organizations. As far as morale of, you know, working on different projects and stuff, I know at least some engineers would relish the opportunity to work on some different exciting projects that are outside their norm, but I can't speak for everybody. Those are a couple of my thoughts on that. I don't know if the rest of the team has any comments.
Yeah, I think, you know, as far as the labor sharing service goes, we want to make sure that engineers are not completely overloaded with projects. SYMBIOTE's going to be taking, you know, sort of a full-time engineer and trying to task them appropriately. Obviously, there's going to be engineers with 30 years of experience. There's going to be engineers with 20. There's going to be engineers with 10, and some just out of college. We recognize that, and the labor sharing service would have the skill sets of those engineers and also try to balance the load based on project priority. So when, you know, a high value project is in the queue, that project needs help, we're going to try to put the best people on that project to help. And some of that data that's going to indicate whether or not we should put that engineer on there is going to come from the project themselves. They'll submit a labor ticket essentially into the system. That ticket will include certain fields and it'll help SYMBIOTE look for some of that stuff. But it should be able to do the labor tracking. So does that kind of help answer your question there, Ken?
Yes, sir.
Thank you.
And then my second part was in 2018, Cubic rolled out a company-wide SAP implementation to try and address a lot of this. Within those silos that exist today, there are workarounds because of features that are missing from SAP or things that aren't quite working right still, right, 4 years after the rollout. Does SYMBIOTE entirely replace SAP or does it augment it? And if so, I guess which direction are you going in that regard? And
yeah, so I think Jason can probably help us with that. He's a little more familiar with that part.
Sure. So the SAP access we have today, the training for it presents a hurdle for most users to easily access the system. And there's a number of data systems that we actually have today where they actually pull from SAP. So we don't view it as replacing SAP as much as we view it as complementing SAP and the other databases and data sets that we have available and making it a easy to use interface as opposed to having to remember a 15-line alphanumeric T code to pull the right data from SAP, if that makes sense.
Yep, absolutely. And I did just want to add this isn't a question, but considering how much time we're spending on a daily basis on supply chain things, I think this is a really critical project that you know, the Cubic needs to get its head wrapped around. Literally 2 hours every day, we're in these integrated supply chain war room meetings trying to figure out how we can address this backlog problem that you mentioned. So definitely wanted to say thanks for making this your project. It's a huge problem that we have to overcome, and I'm glad we have people looking at alternative ways to do it instead of just continuing to grind our our talent against the state of the supply chain. So thank you.
Thank you, Ken, for the question and the feedback. It's much appreciated. Professor Kruger.
Yeah, thanks to the team for the presentation. I think this is a very interesting system and design. Have you thought about turning this into a platform? Because I'm sure that Cubic is not the only company that has similar challenges. And I see one of the key value propositions here that you have an ability to bring domain knowledge from inside Cubic into this matching process and labor sharing process. So if you make this modular, other companies might be interested in this as well. Is this on your roadmap?
New division. That's what we would consider, to be a phase 3 aspiration. Our intent is in phase 1 is to get the base infrastructure up and running and be very concise, focus on one problem, show that SYMBIOTE provides return value on that problem to all of Cubic. The concern is if we try to tackle too many things simultaneously, we'll exhaust the funding and not have achieved a successful implementation. So phase 1 is to get the base infrastructure in place to return immediate value to Cubic, focused on supply chain impacts with suppliers and excess inventory that's accumulated across the enterprise. With phase 2, more focus on program execution. I do like the idea of taking what we've done here and expanding it to an enterprise where we could package it and sell it as a software suite to other organizations. But the initial focus on SYMBIOTE has been unlocking the value inside of Cubic.
No, that's really great. So I think doing one thing first and then the other is always a good idea. My point is try to be modular with your core features so that you could expand them if an external use case arises.
Oh, absolutely. And it's our intent to do so. We're basing our system off some existing modular technology that's built around Kubernetes and microservices. We found that to be very attractive from a number of perspectives. First off, with Kubernetes, we can containerize the different microservices and features that we need. We can also spin up additional clusters to address load balancing and concurrence as the number of users across the enterprise start to use the system more and more. And as Cubic continues to grow and become more profitable, we feel that it offers a very modular and scalable architecture. We also like the idea of microservices because as one of the things that we learned through this program, working with you, is the Stringler Fig design pattern to take advantage of existing interfaces, investments that we have today with databases, tool sets and systems that we have, and we can easily add in new capability as Cubic continues to grow and evolve.
Thank you.
Thank you, Professor Kruger. We have 2 more hands. Professor Romer.
Well, thank you, guys. Obviously, a topic near and dear my heart. Very interesting. My question is actually a simple yes or no question. So let me explain why I asked it. The question is, do you have a heavyweight executive champion for that who is willing to put all her or his time into supply chain management? Without that, this is an uphill battle. You mentioned culture change is required. You need a champion to support this. If I work with Amazon, I don't need to explain anyone that supply chain management important is, right? If I work with pharmaceutical, which I do a lot, I refuse to work with them if I don't get the feel that supply chain management is taken seriously. And pharma learns this, right? And literally, if a 2 cents aluminum part is missing, we cannot ship cancer medication. So you need to have a compelling story why this is absolutely crucial to the company, to the mission of the company, and get an executive champion. Maybe the answer to my initial question is yes, we have strong executive support. Then I just sermonized here for for half a minute without much value. But what are your thoughts on this? Do you have this, or how would you go about getting support? Thank you.
Excellent question. And to answer your question, we do not have a single executive supporting us. We have multiple executives supporting Team Symbiote.
Yeah, and to add to that,
you want to own it.
Yes, we've gotten lots of support. A lot of folks that we've exposed to the idea, they're like, "This is great. We need to go talk to 2 or 3 more people on the leadership team." So everybody that we've presented to, all the executives, they've been very supportive and backing of what we're trying to do here.
I would just add to that, Jason, that supply chain is a big focus at Cubic right now. And when Cubic was recently bought by private investors, one of the first things they did was hire a new direct report to the CEO who is in charge of integrated supply chain. So it's a big focus on Cubic right now.
Excellent. Thank you.
Thanks for that question, Professor Romer. Professor Zach?
I think I just have a couple of comments about the interactions you just had with Professor Kruger and Professor Romer. So I'll start with Professor Romer's comment because it was most recent. I think it's worthwhile recognizing a difference between an executive sponsor and people thinking it's a good idea and being supportive. I think the way I would interpret Professor Romer's words, but I would certainly encourage you to be thinking about it in those ways. A sponsor is someone who has put their reputation on the line and stuck their neck out to make this happen. And they're senior and influential. You need to be going after somebody like that. And that's what it means to have support. The comment and interaction you guys had with Professor Kruger, I would encourage you to, so there's always a trade-off between the spreading the energy between too many unfocused things and putting all the eggs in one basket. Since everyone here is an adult, I would still encourage you to continue exploring use cases outside of Cubic, which are going to be similar enough. So following Professor Kruger's advice of making things modular is critical, but gathering use cases where you're able to at least envision an architecture which can meet objectives not only of Cubic, but potential other clients would be continuously useful for you as you acquire more and more people who would be supportive of the cause, and you may be acquiring more executive sponsors and not only at Cubic. Otherwise, I like the presentation. I think it's a worthy task, and I think you're approaching it in a fine way.
Thank you. Thank you.
Thank you, Professor Zach. Any other questions? Well, there's about 5 more minutes, and I'm not going to let it go to waste. So my question to the team is, have you thought about what sorts of incentives you might put into place to encourage people to team, as a team of teams across all of Cubic rather than just being focused in their one individual division? And how would you construct those in such a way that you wouldn't get sort of undesired behaviors and side effects? So what are your thoughts about that space?
So I think it was recently Noah actually kind of came up with an idea. We need to incentivize projects to grab from this excess parts inventory we have, essentially. So in thinking about that, we literally thought, well, why not give engineers cash incentives to grab from excess inventory and draw that down? It could help generate revenue. That's one of the examples of incentives we were thinking. That's going to help fund the first phase of Symbiote by doing that. But other incentives could be just make the system really good. I think Ken alluded to earlier, they're spending a lot of time going into different programs and being in meetings and trying to make, you know, things work with the way that things are today to help the supply chain issues we have. If, you know, we were to design SYMBIOTE in such a way that it integrates well, it's got an easy UI, and it will basically incentivize itself, we hope, you know, from its own design, and just shorten people's time looking for stuff, and basically make their work easier, you know. So as far as other incentives, I don't know if anyone else has any other comments on that. We haven't really talked about too many other things, but Noah, maybe.
John, correct me if I'm wrong, but is your main question pointed towards the aspect of working across different divisions?
You know, it's this issue of the silos that you have, which are creating the problems, you know, are the challenge with working with these types of systems and doing things that may be in the greater good of Cubic, but maybe, you know, cause some issues for your particular division. And so it's a big problem, you know, and there are many different ways to address it. And I was just wondering how you'd been thinking about that, what sorts of actions you're thinking of taking.
Yeah, well, thinking about the Managing for Happiness book that we read as part of this program, they talked a lot about bonuses and how using them, you can get those undesired behaviors you talked about. So, you know, whatever incentive structure we go with, I think we have to be very careful that we don't accidentally encourage the wrong behavior. So that's something that, you know, I think would need to be very well thought out. And we haven't, you know, fully developed any plan for that particular aspect. But I'm certainly always personally open to financial incentives for encouraging employee behaviors that you desire. But at the same time, I mean, you work at Cubic, you get paid to work here. If somebody asks you to do a job, you should do it, right? I mean, you don't get a bonus for coming to work, right? So I understand what you're saying.
Yeah, I mean, to your point, you know, for example, an incentive to engineers to use parts from the excess inventory, a very clever engineer could design a lot of parts unnecessarily into their system that could draw down the inventory and make them a bundle individually, but wouldn't be so great for Cubic. And so one of the things you might consider is, you know, how do you get people within different divisions of Cubic connected to other divisions of Cubic? You know, what sorts of cross-pollination do you do in order to actually get people to understand, you know, there are other partners in other divisions? And I think, for example, your labor sharing is a way of doing that sort of thing where people move around and they see it as, you know, as a desirable thing to have exposure to other divisions. And you start creating that network of connections that will increase your empathy and will help you sort of work together. So if you can look at like McChrystal's Team of Team books, it will give you some examples of how you might go about that. But those cultural issues are major, major challenges, and they require the sorts of champions, you know, that Professor Romer and Professor Zach were talking about, because those are the really big issues that you're going to face. So I really want to thank the team. Again, thank you for the excellent questions. Great presentation. The time is now up and we'll be meeting again in approximately 14 minutes. So thanks all.
Thank you.
Thanks.
Thank you, Professor. Thank you, Professor Wade. Good morning, esteemed professors, valued guests, and fellow classmates. We have the distinct pleasure of sharing our team project, C4I Proactive Readiness, with you all today. On behalf of Michael Itakura, Jacqueline Spencer, Andrew Valenzuela, and myself, Michael Winslow, we welcome you to our presentation. We will have time at the end for any questions. We wanted to start off by sharing a story, which we believe will paint a picture of the importance of our project and will provide valuable context. This story is partially inspired by one of the scenes in the novel 2034, a great read, especially if you work with the Navy. IT-1 Nicholas Gooden is stationed on the USS Sterett. The USS Sterett, a modern-day destroyer, is doing a freedom of navigation patrol in the South China Sea.
The mood on the ship is tense due to recent attacks in the region.
Nick has been up for 14 hours in the frigid and loud radio room and is busily reconfiguring a radio to operate in a stealth mode. The Starret has been tasked to investigate a suspicious ship.
The commanding officer and the combat systems officer, Nick's boss, walk into the radio room upset because he can't maintain situational awareness because his primary command and control application is down and the CO doesn't know if there are any threats outside. Nick panics as he realizes that the data center has crashed and quickly grabs his 1,727-page manual to troubleshoot the issues.
The Starret reaches the suspicious ship, and they realize they need backup, but comms aren't ready. The next thing the crew hears is the sound of a torpedo alert blazing over the intercom. Moments later, the ship violently shakes from a crippling impact. A cold rush of water fills the vessel, and the once powerful warship, with over 380 sailors, slowly plummets to her final resting place on the bottom of the South China Sea.
In January 2021, the Chief of Naval Operations released his navigation plan, and one of the 4 key areas was readiness. Deliver a more ready fleet. This is continued in the NAV Plan 2022, which states that we must ensure delivery to generate the decision advantage. One of the greatest ironies that our Navy faces today is that the most sophisticated tactical network capabilities our sailors have ever seen are mapped to a complicated and often misaligned web of care and support services. This system is challenged to keep pace with the high volume of trouble tickets, onboard technical assist visits, and critical system outages that occur every day on Navy vessels around the world. With all the technology that exists, why not create a predictive system that does away with manual methods to sustain C4I systems? A system that resolves issues proactively.
Let's go back to IT1 Nicholas Gooden. Now imagine a week before the torpedo attack, Nick had received a call from the shore support team informing him that there are configuration errors on his C4I system that would create system instability.
Nick then receives a push notification from the data center, informing him that the self-healing configuration changes made to resolve the network instability were made to resolve the network instability. Nick is able to keep things running smoothly and now operationally ready for the upcoming conflict.
Now, from that story, you have a mental visualization of what the problem is. C4I systems are difficult to use and sustain, and when problems arise, troubleshooting is complicated and time-consuming, ultimately impacting operational readiness. Now, this is what our project, C4I Proactive Readiness, or CPR, is about, solving this problem. How? By providing capabilities that increase warfighter self-sufficiency. The white section of this slide represents the core capabilities CPR will deliver to the warfighter to equip them to achieve their mission. And to quote the CNO, win in day-to-day competition, in crisis, and in conflict. And we'll dive deeper into these capabilities throughout the brief. The benefits and business side of CPR. Number 1, an increase in operational readiness, which has been the Navy's top priority. CPR increases C4I systems uptime and availability, which leads to increased operational readiness. And as you heard from our story about IT1 Nicholas Gooden, ultimately saves lives. We're also looking at some cost savings with a net present value for the project of around $8 million internal to NAVWAR, but that number doesn't include the cost savings impact on the rest of the Navy enterprise, such as regional maintenance centers and type commanders that pay for costly network rooms, training, casualty support, and other onboard tech assist. So the cost avoidance of these events adds to the value of CPR. Now, towards the end of the brief, we'll talk about the steps to make CPR a reality, our 4-phase implementation strategy, and how we intend to build trust in our user base throughout those phases. So we provide a product that our warfighters are excited to use and that helps them achieve their mission.
Already noted earlier, and based on numerous conversations with our project stakeholders, is that the front matter of our problem is the increasing complexity of the C4I landscape, particularly for our operators at sea. One key factor is that our near-peer competitors and adversaries are also expanding their technological advances in the information domain. A crucial differentiator for our commanders at sea and for the stakeholders who support them is to address the enormity of sustaining the health of the C4I environment of this complex adaptive system of systems across the spectrum from peace to wartime. The harsh reality is that the burden when things go wrong largely rests on a handful of sailors that are not adequately resourced to resolve the C4I failures at the rate that they are occurring. The end result is affecting operational readiness and the ever-increasing cost to conduct ad hoc tech assists and other unplanned support to our sailors out at sea.
But we have a solution. That world in which IT1NIC can keep the USS Sterett systems operationally ready at all times is possible. It's possible with our system, CPR. CPR will detect and resolve C4I system failures, both automatically and manually, as it interacts with the warfighter to guide troubleshooting. CPR will connect the warfighter with off-ship support, automated trouble ticket routing, and dashboards with real-time system status and analytics. And just like that, the Navy sustainment experience is transformed from reactive to proactive.
As we started to transition from our problem statement to concept formulation to the solution, the critical first step was to identify the use case scenarios. This enabled us to identify our actors and our actions. Shown here are 3 of the use cases used to verify our operational concept, which Andrew will explain next.
For automatically resolving C4I system faults and failures, what this use case diagram shows is CPR collecting data from any number of C4I systems. CPR takes that data and then analyzes performance and configurations to determine if there are any deviations that would impact the system. Depending on how the warfighter configures CPR, it can then either automatically resolve the failure or wait until the warfighter approves the fix before executing the change. CPR then logs the event into the data repository. So we build upon that collection of data to analyze to predict future events. Now, hardware failures are typically addressed when they happen. The ship reacts when a part fails, and they manually submit a trouble ticket and execute the parts replacement process. Now, with CPR actively learning about hardware faults and monitoring the health status of C4I systems, what this use case shows is CPR detecting a failed part or predicting a part near failure, and then sending an automated trouble ticket and triggering the parts replacement process. When the part arrives, CPR also provides the user step-by-step digital instructions on completing the part swap. Now, similar to detecting hardware failures, CPR uses those same data analysis techniques to provide a dynamic maintenance schedule. So this use case shows how CPR uses data collected from C4I systems to determine when a maintenance task should be run for that specific system, rather than relying on time-based schedule where maintenance could potentially be done too late and lead to a system failure.
With these and many more use cases in mind, our team designed CPR, a robust, highly integrated AI machine learning powered system of systems to automatically prevent, report, and resolve failures on C4I systems. By design, CPR is built on the Consolidated Afloat Network Enterprise System, or CANES, which serves as the infrastructure for all C4I systems on ships and submarines. CPR collects and aggregates C4I systems performance data, which it feeds to its logic and AI engines, as well as displays to the user. The logic engine defines C4I configuration baselines, system performance thresholds, and up-to-date patch requirements. Based on the data it receives, CPR determines whether there's a fault that requires remediation and whether to auto-remediate or request a manual fix. The AI engine learns C4I systems behaviors, detecting behavior patterns and checking them against defined expected behaviors. It also ingests knowledge sources, such as C4I system manuals, to inform its own knowledge of C4I systems and ready responses to inquiring users via AI chat. The AI engine also learns from and contributes to two key features of the user experience layer: AI chat and data visualization. Data visualization provides users performance, configuration, and patch status of all C4I systems. It indicates which systems CPR recently remediated and which systems still require attention. The visuals also include a series of filterable dashboards which grant the user insight on C4I system trends over time. AI chat, both on desktop and mobile devices, enables bidirectional communication between the user and CPR. The AI chatbot can notify an on-duty tech of a system fault that requires their manual fix and provide the tech with exact knowledge to complete the task. The user can ask the chatbot how to use or troubleshoot a C4I system, and the chatbot will reply with correct answers. The chatbot can submit and check the status of trouble tickets and can connect the user to off-ship support via live chat. Our team has iteratively designed CPR's architecture using model-based systems engineering methods and tools, keeping our models data-driven and executable. We have diagrammed CPR's architecture using Spark's Enterprise Architect, and our files can be imported into Cameo Magic Draw, the tool of choice for the Navy. Altogether, our team has diagrammed 27 viewpoints, which are SysML and UML compliant, and which are required by the DoD Architecture Framework, or DODAF. As we develop each viewpoint, we learn so much about what it would take for CPR to fulfill our use cases. Many diagrams, such as state machines, forced us to think deeper about how each capability will work together and how users will interact with the system. Each time we looked at CPR from different viewpoints, we refined CPR structure and behaviors to make CPR suitable, sustainable, and scalable for the Navy's needs. We refined CPR's architecture even further as we continue to engage our stakeholders.
Stakeholder engagement has been critical to our project from the start to ensure CPR aligns with our stakeholders' vision and concerns. We identified the NAVWAR's Fleet Readiness Directorate, or FRD, technical director as a critical stakeholder due to their role in engaging and representing NAVWAR directly to the fleet. Their technical director was a huge proponent of CPR and thought it would address critical challenges that FRD was facing each and every day. We also identified and engaged with the CANES Principal Acquisition Program Manager, or PAPM, as a primary stakeholder for the project. The CANES PAPM owns the cost, schedule, and performance of CANES, the foundational C4I system for the Navy, and is our planned transition partner. The CANES PAPM was similarly excited about the effort, simply putting that they love it, as it directly addressed the demand that the program was receiving from the fleet. They encouraged us to think about how CPR could help with the cyber mission, particularly with configuration and patch management, which got incorporated into our design. In addition to meeting with the CANES PAPM, we met with the CANES lead engineer. Similarly, the feedback on the CPR design, architecture, and impact was favorably received. We discussed transition potentials with ongoing initiatives, including the in development and now prototyping Fuse Pulse system and the Nadia initiative. From the onset, we identified our NIWC Pacific Department Head for Communications and Networks, or CNN, as a critical stakeholder. The CNN department is responsible for executing the engineering of the CANES program. She was instrumental in helping us come up with the project concept and has been in constant communication with our team throughout the project, providing thoughts, insights, and guidance. Finally, I had the distinct pleasure to visit our 4 deployed naval forces in Yokosuka, Japan a few months ago. During that trip, I was able to have conversations with the sailors that use and sustain CANES and C4I systems each and every day, as well as the commanding officers of those ships. The response from the warfighters at the tip of the spear was overwhelmingly welcoming of a capability such as CPR. Altogether, our stakeholders believe that CPR delivers many incredible benefits to the Navy, which we're going to share with you today. In the CNO's Navigation Plan 2022, the CNO states that the readiness of the fleet remains the Navy's top priority. CPR directly improves operational readiness of the fleet. CPR does this by utilizing predictive analytics in order to identify faults before they become issues, preventing system downtime and allowing the power of information to be available when it is needed. Additionally, CPR will be collecting and assessing the performance and faults of C4I systems, not just locally, but also globally. This global view, powered by artificial intelligence and machine learning, will enable enterprise learning across the fleet, allowing the Navy to identify and resolve systemic issues that have gone unnoticed previously. By collecting performance, configuration, and fault data, CPR will have unparalleled insights in the state of C4I systems, enabling it to help in the defensive cyber mission to include configuration management, patch monitoring, and detecting anomalous behaviors.
So expanding on the theme of readiness, one question is, how can the Navy enable mastery of all domain fleet operations? The answer is that our sailors are key enablers to all domain operational readiness. The bottom tagline here, trained, educated, and resilient sailors remain our asymmetric advantage. Now that emphasizes the importance of having a self-sufficient fleet. In the Navy's current state, troubleshooting systems is difficult and lengthy, and often requires expertise not on the ship. But with CPR, our sailors will have a partner that provides insights based on that analytics Mike just talked about to help sailors troubleshoot their C4I systems. Now, oftentimes it's also helpful to bounce ideas off of someone when troubleshooting. So that's where CPR's AI chat could come in and provide relevant information to guide our sailors through the troubleshooting process. Now, regular maintenance is also a critical piece of maintaining C4I systems. CPR will provide the sailors a predictive maintenance schedule based on need, instead of the more commonly used time-based maintenance schedule. And some of these maintenance functions will even be automated. The result of providing these capabilities, CPR is arming the fleet with the tools needed to independently maintain their systems and ultimately increase operational readiness.
Titled here is another overarching benefit to CPR. We ran through the CPR architecture layers previously, which are now shown at a high level to the left. This is to convey that our design enables the features shown by arrows point in terms of the outcomes that ultimately lead to the contribution to the C4I uptime and availability status. Through data collection and how CPR leverages the CANES environment and how it's integrated into other afloat C4I applications, we cast a wide net in order to continuously monitor performance data and configuration baselines. The other aspects of the architecture, to include user experience, also come into play to produce an outcome which produces a highly disciplined configuration management process across the enterprise. Once we have this disciplined performance and configuration baselines properly managed, CPR will become exceptionally sensitized to deviations that will allow the system to rapidly respond to sources of faults. CPR will not only be assisting sailors through real-time troubleshooting by automatically detecting and resolving anomalies, but the system will also be collecting, aggregating, and analyzing data to monitor trends and systemic issues. CPR will be constantly learning. This is envisioned to improve the event detection accuracy and the use of patterns that will enable the system to put the predictive into the proactive part of the CPR equation. In addition to where the AI and logic engines support the features noted above, CPR will learn and adapt in this event-driven construct to ultimately enhance the throughput of events that are triggered by the detection of real-time anomalies and the actions to predict and prevent anomalies from occurring. At the end of the day, the so what to the CPR mission is that it provides a critical lifeline to all warfare mission areas.
CPR will reduce cyber risk to the ship and to the fleet with the following capabilities: C4I systems configuration management, patch monitoring, and detection of anomalous behaviors. CPR will remediate the vulnerabilities it detects in real time. CPR also will share the performance, configuration, and fault data it collects and analyzes with teams responsible for the cybersecurity of the Navy, for the additional benefit of empowering larger cyber missions.
A key principle of CPR is that it will increase the operational readiness of the fleet. CPR is able to accomplish this while simultaneously reducing the cost to sustain a fleet, freeing up valuable resources that can be utilized in order to deliver additional capabilities to the fleet. Over the next 15 years, CPR will reduce the staffing required to sustain canes and other key naval C4I systems, resulting in an overall cost savings of $39.4 million. When including the development cost to iteratively develop and to deploy CPR, the net present value savings of the program will be $7.9 million across the system lifecycle. The largest risk to the program is the warfighter's adoption of automated recommendations and changes to the fleet. This could be mitigated by a phased rollout of the system, focusing on the faults that are the most common and that require the most resources to resolve first, and then tackling other faults. We also will ramp up the automation, starting with recommendations only. By using this iterative approach, delaying the decision to tackle more of the faults and the automation of resolution, we thus have more optionality. And CPR will have a real option value savings of $8.8 million across the system lifecycle. Ultimately, CPR will increase the number of nines of system availability while also saving the Navy money. Being mindful of our goal to ultimately build user trust, we have planned a 4-phase approach to go from the CPR concept to a fleet-wide deployment. Our development will be built upon the foundation of Agile principles and DevSecOps. Our early development phase will start off with a passive data collection only system, deploying a simple laptop that will be used to form the foundation of our future development. The goal of this phase is to get this capability deployed as expeditiously as possible to start collecting system level data. In parallel to deploying this laptop, we'll go through the trouble tickets and casualty reports to start conducting our analysis and look time-consuming impactful faults. The results of this analysis will be shared with our stakeholders as well as the engineering teams for incorporation into future baselines. The first official phase will upgrade the laptop system to add a lightweight data analysis engine. This engine will focus on a very limited number of faults, and the results and recommendations for resolving the faults will be provided directly to the CPR development team for validation purposes. The results found during this phase will be shared with our stakeholders, and any urgent findings would be shared with the fleet. The second phase will then deploy the full system on the Cane's virtualized computing infrastructure, utilizing several enterprise services provided by the Agile Core Services, or ACS. This phase will target the high-impact, hard-to-solve faults and will provide sailors with recommendations by automatically resolving faults. Throughout this phase of development, the CPR team will reach out to the fleet for customer and user engagement sessions. The third phase will be remotely pushed software-only upgrade that implements more faults and will enable the option for CPR to automatically resolve faults as they are detected. This approach will enable us to get the data that we need to prioritize our development will enable us to validate the solution, and then will enable the users to see what CPR can do, building trust in the solution before we roll out the full capabilities.
Thank you so much for listening to our story about IT1NIC and CPR. Please invest in CPR and work with us to make our Navy fleet ready for anything. At this time, we welcome any questions or comments you may wish to discuss.
Thank you, team. Folks, raise your hands and we'll start raising those questions to the team. Hi, Susie. You've got the floor for the first question.
Hi, great brief, you guys. I really enjoyed that. Couple questions. I think, Mike, you mentioned ACS. What does the interface with the C4I systems look like? Is there an API that's being developed to collect the data, or does changes need to be made on the application side? Of course, there's Canes, but are there other applications that you're going to interface to collect data? And then the second question I had was just in your design, there's the potential for aggregating large amounts of data. So what was the plan for that? Thank you.
Hey, Susie. Great questions. The first one on ACS and the API. So we plan to leverage a bunch of the ACS services. We purposefully didn't put them on this briefing, but we can provide you these specific services. But it's like the data broker, the data storage, the security solution that ACS provides. And for Canes, our plan would be to have two different types of data collectors. One that is a receive-only data collector, and the second one is an installable data collector. And for both of those, we'd have an API that would allow us to define the data that we collect and how we collect it from the different applications and from Canes itself. On your second question on the potential for aggregating large amounts of data, completely concur with you on that. And part of our data management plan would be figuring out the minimum data that we need to store in order to formulate the heuristics that we need to do. Part of our data collection system includes a data reducer in order to reduce the data down to the minimum data we need to do the analytics. And one of the things we're going to have to design into the system is how much data we provide upstream up the SATCOM channels in order to provide remote access to the data. So those are all things that we're thinking about and would need to continue to track as we develop this system.
Thank you. I actually have one more follow-on question, if you don't mind. On the cyber monitoring and patching, will your system allow for incorporation of COTS or GOTS tools to do that anomalous behavior detection? Does it, can you incorporate other outside third-party kind of systems into your system? Over.
Yes, it's our plan as part of an early phase of our project to evaluate which tools would be best for integration. But yes, we plan on incorporating COTS when possible, GOTS when more appropriate, and so on.
Just to expand on Jacqueline's answer.
Yeah.
One of the key systems that we see ourselves feeding into is Shark Cage and some of the other systems that PMW 130 are fielding. And so they are an external interface to our system so that we are yet another data source that they can leverage as they do their cyber defense mission.
All right, thank you. Thanks, guys.
Bill, you've got the floor. But I think you're muted somehow. What I'll do is Tara, if you want to ask your question, then we'll get back to Bill when he's got audio.
Hey, great. Thank you very much. Congratulations, guys, and everybody in the AESE program. Great job in getting to the end of this. I wanted to ask the team that a fantastic idea of being to create this program. But my question is, this seems to be looking at a concept of solving a problem, and you're calling it proactive, and I agree, because you're trying to predict and get ahead of the problems or help them solve the problems on the platform. But have you considered, there's two questions to this, have you considered one of, I would suggest maybe this is a little bit reactive because the problem is occurring on this platform. Can this data then be brought left, or this work or concept be brought left so that less faults occur on the ship, in the fleet, in the system, and can be discovered in the design cycle, or let's say in the testing cycle? So you have less faults in the fleet. And my second part of the question is that you're focusing on CANES, which is, we all know, is the biggest program. It's the backbone on the ship, right? Have you considered the concept of this being reusable to support other C4I programs? Over.
Yeah, so Tara, for the first part of your question about considering if we could resolve faults in the design phase, that was considered as part of our data collection. The data that we collect from the ships that we determine are faults or failures that are on the ship, that's going to be cycled back to either upgrade the design of the current systems that are experiencing those faults, or for future designs like future CANES variants, future GEEKS variants, whatever programs that we decide that, or that the data determines will need those upgrades. For example, let's just say we have a commonly failed part. And then for future designs, maybe we could consider one that would have a smaller failure rate, or a completely different design from that. So that is part of what we considered with the data that we're doing here. It's not just for faults on the ship, but feeding back into the engineering process as well.
Does that align into, sorry to interrupt, but does that, I know previous years there was a presentation from NIWC about a digital twin. Does this fall into the concept of, or connect into digital twin concepts? Over.
Yeah, we want to feed this data into the digital twin instantiation of CANES. I'll say currently we do business by getting these Corona assessment reports every several years. And so part of the goal of this would be to speed up that cycle from information and things happening on the ships to us making changes in the baseline. So that definitely is something that we're considering, hoping to tackle.
Awesome, thank you.
So Bill, are you able to use audio?
Well, I don't know. Can you hear me now?
Excellent.
Okay, sweet.
It's your floor.
Okay, thanks very much. So team, terrific brief. I truly appreciate you guys going after trying to get to the nirvana of readiness that the CNO certainly is looking for, and has been a challenge forever. When you said your initial phase is to do data collection, place the laptop on a ship, I'm sure I don't need to tell you that there are lots of different versions out there. So were you intending to sort of prototype on one or two big ships, or were you, how much data collection did you think is sort of the phase 0 part, that since they all seem to be snowflakes still, we haven't gotten to the place where we have singular configurations even by class of ship? Over.
Yeah, I'll try and tackle that, and anybody else can pile on. I think our plan would be to target each major CANES baseline, and we'd start in the DICE lab. So as I'm sure you're familiar, we have, I want to say, 4 or 5 CANES decks down the lab. And so we'd want to deploy the laptop there so we could hit the hardware 1, software 1, the hardware 1 mod 1, the hardware 1.2 and software 3 ships, and then the newer hardware 2, software 4 ships. So that would be kind of our general strategy, and mirroring that same capability or same deployment strategy in the fleet.
Michael, let me add to that. We also would ideally like to target representation of each major class. We recognize that footprints are different and activities are different from ship to ship. And so we'd like to hit aircraft carriers, destroyers, submarines, just so we're getting as representative of the reality of data out there as possible.
Excellent. And so I guess my last question, and I'm not even sure it's appropriate in the academic setting, but so when you went to 160, did they say, yep, we're in to put this in the POM and start funding this idea? Because they desperately need it. There's no question about that part.
Yeah, in the talks with CAIR, the 160 PAPM, we talked a bit about this, and they have the congressional ad for the Nadia initiative, which was something like a $50 million investment from Congress to tackle some of these challenges. And so our plan was to take our design and architecture, more or less hand it over to the Nadia team and work with them to implement the design. So there's actually, the good news story is there's actually already a team that has the charter of taking AI and applying it to CANES. And this is one of the use cases that we're working with them on and implementing.
Excellent. You can bet that I will be following up with you back at the workplace. Thanks very much, guys. Great brief.
Thanks, Bill, for the support. Really appreciate you being here. Other questions? We have a little bit more time. Well, I'm not going to let free time go. So, there's been some conversation in the back chat, and also conversations I've had with the team as well, and looking at the the net present value, and really looking at narrowly with respect to savings, and really savings in a sort of limited scope. So for me, looking at a project like this and seeing 8 million, that's basically a break even. And so when you think about the value of readiness, how do you actually provide value on that, or with respect to risk assessment of losing capabilities or losing lives or losing ships? Does the Navy do sort of estimation of those sorts of events or facts to understand it? And how does one value the difference between a ship with 90% readiness versus 3 or 4 nines of readiness?
We do a lot of analysis at different security levels on operational readiness and the value that each platform provides in order to support a mission thread. We struggled a little bit with capturing because there's so much different costs and so we focused on the NAVWOR costs and bills in particular, and Andrew alluded to that when he first went through this slide. There's also the regional maintenance centers or RMCs that invest a lot of costs. There's also the money that the fleet spends on doing all kinds of tech assists and other types of things. But then, yeah, I mean, as you said, there's like a certain, I think an aircraft carrier nowadays costs $5 or $6 billion just for the carrier. And then you got another $1 billion of aircraft sitting on the carrier. So there's a lot of potential money savings. If we could save one of them, we've definitely paid for this program oodles full. So I don't know how to give you we struggled on coming up with a tangible number that we could really put on it, like with a certain probability of loss of a platform, and then tying it to like an expected value kind of equation.
I mean, one way to do it would be to look, I mean, if you have the cases of outages and you start looking at outage, how much time were there outages actually in place and what capabilities did you lose? And if you're able to reduce those by a certain percentage, you might understand, how much more, what the readiness is, and then try to get some valuation of that. Professor Romer has a hand up, and so I want to make sure he has time. Professor Romer, the floor is yours.
Yeah, thank you, John. I was also thinking about the NPV, and I wonder, are we pricing this correctly? If I'm avoiding potential losses in the $1 billion area, why can't I monetize this better? I mean, 7.9 million seems to me like, yeah, okay, that could be positive, could be negative. I don't know. It almost detracts from your presentation. If you want to present that in the future, I'm not sure if I would even put that number in it. Ever since I saw that number, I've been distracted thinking about it, and I think so. I don't know. I don't have any advice for you, but I would be rethinking how I would present that.
And thank you for that, Professor. We also struggled with whether to show the number or not. We knew that if we didn't show the number, there would be a wondering of what's the NPV of this project. But we also recognize that if we were to take this and present it to some of our stakeholders today and to, you know, our larger stakeholder community, this is far less important than the benefits being introduced of increasing overall operational readiness and uptime availability of C4I systems. So that would certainly be where our emphasis would be. It's great that there's also cost savings, and certainly with more cost information from other areas that, like Michael was speaking to, that were unavailable to us at the time. If we were to have an opportunity to look at we expect to see cost savings there too that would help in those numbers. But yes, we hear you on the number being distracting, and it was like damned if you do, damned if you don't, including in our presentation or not.
I think working on the program office side at NAVWAR, it's definitely a shifting paradigm. I think we didn't want to do is overplay the numbers here, but I think as you look at the shifting culture of what we're trying to do relative to the entire Navy in terms of implementing digital transformation in these larger initiatives, I think we've got to kind of relook at, you know, as we continue to engage with stakeholders and looking at the broader ConOps of what we're trying to fall into. And duly noted that I think we need to kind of have a shift there where I'm traditionally used to seeing where we stick to more conservative numbers in terms of should cost and more specific financial data. But I think there's definitely a paradigm there to make it to shift that paradigm and to show the perspective of what we're trying to do here.
Well, I'm going to, Bill, I'm going to give you the floor, given your position and support here, and then we'll get to Professor Zach right after you.
Professor Zach, it's okay if he wants to go first. I'm good with that. Okay, so all I'm going to say to the team is that I think that the professors here are making a phenomenally important point that we've been historically bad at when we try to sell our ideas. And so we typically take a look at the cost by program that we might save or the improvement we make in that particular program. When the chat and the conversation we've been having the past few minutes points at the fact that there are real costs across a much broader spectrum that we should capture when we're going to sell programs. So the discussion is right on the mark. Guys, it's all my fault, as always, that we haven't done a better job of that. But I think we should take advantage of the great advice we're getting here. And we could make some estimates, and we can, as long as we can explain the estimate. Okay, so somebody will challenge, I don't think it costs that much to run a carrier for a day. Okay, give me a better number for it. But it still is a very large number. If the carrier can't operate for a couple of days, that is a huge number. It would, all of the, you know, the $8 million would pale by comparison just for that, much less the, you know, as Professor Levis talked about, the loss of life in a real scenario, you know, if we can't do C4I appropriately. So there's some really great input here that we could use very, very functionally to increase the ability for us to get interest and investment in C4I programs. So thanks to the team, and my sincere thanks to the professors for sort of bringing some light on the fault and the way that we've been selling C4I programs forever. Thank you very much.
Thank you, Bill. Professor Zach?
I just want to give a slightly different coloring to that 7.9 million, which obviously everybody noticed. It's not bothering me nearly as much as it bothers some others, I think, because almost everything we're doing is an opinion. You interpret it a little bit differently and the opinion changes. The point here I see as analogous to asking whether something is ethical and legal. So if the answer is, well, it's not exactly ethical and possibly illegal, you now get into a different realm where you have to talk to lawyers and see how you're going to whitewash this. With NPV, it's the same thing. If NPV is negative, all of a sudden you need to go and talk to finance people and they're really concerned. If the NPV is positive, it is basically equivalent to something being ethical and legal, and now you want to look at what benefits it will bring. So the fact that you've done the calculation and it's positive is a great thing. And now you probably don't need to put it on page 1.
Thank you for that, Professor Zach, much appreciated. Our time has concluded. I want to thank the team for doing a wonderful job, and everyone who's attended and has posed such excellent questions and discussion. And I truly hope that this, like the other projects, moves forward. Being, a U.S. citizen, I care deeply, and I would say I've seen the presentation a couple of times, and I still get chills and shivers up and down my spine when you go through that introduction. I found that to be deeply moving and extremely persuasive. So thanks again for that. I appreciate it. So we will take a break for 1 hour. I believe that's the schedule, and then we will be back to hit the 4th presentation, which will be wildfire suppression, and we'll start that at 1 o'clock. I would ask that the team presenting be back 10 minutes earlier so that we can get your presentation up and running before the start time. Thanks everybody for a wonderful morning. I'm looking forward to an equally great afternoon. Take it away, Team WSpER.
Great, thanks John. Good to be with everyone today. We're Team 2, Team Fire. I'm Hans, and with me we got Udiah, Sam, Diane, Ken, and Husam. We architected a system intended to enable better decision-making on wildfires, and we call it WSpER. Next slide. Systems intended for the fire service. That's all levels of government, everybody who fights wildfire. Next. Wildfire is a pretty big problem today. Impacts are huge. Just last year, we spent billions trying to suppress them. We lost thousands of structures and over 7 million acres burned. Next. But the problem isn't just ours, it's global. I imagine most of you remember the Camp Fire that burned up the town of Paradise in California in 2018, killed 88 people. But many of you may not know that that same year over in Greece, 100 people were killed. Year after that, 30 more people died in China, and satellites actually detected wildfire activity in Greenland. In 2020, 42 million acres burned in Australia. That's about the size of the state of Florida. 2021, similar amount of acreage burned in Siberia. 184,000 wildfires occurred in Brazil. And then just a couple weeks ago, in Northern Africa, 26 more people died. Next. So before we go any further, I just want to make sure that everybody is on the same page. Wanted to talk about wildfire briefly and just emphasize that fire on the landscape has been around for a really long time, hundreds of millions of years. All of that fire is driven by the environment it's burning in. It fuels the weather and the topography. Those fuels are constantly growing, they never stop growing. And in extended drought conditions like we're experiencing now, all of that vegetation will burn. Everything you can see and everything that's in the ground. Next. Now, firefighting. I'm sure most of you, when you think of a firefighter, you think of a structure firefighter and an engine. That's not who we're talking about today. We're talking about wildland fire. Our fires are a little different because they're always moving. And in order to put them out, we got to contain them first. And the way we do that is with fire lines. If we're lucky, we can use existing features like a river or a road. But oftentimes we got to build these fire lines ourselves by removing all the burnable vegetation all the way down to bare mineral soil. We got a lot of tools at our disposal. One of the big ones we use a lot is aircraft, and they matter, but probably not the way you think. A lot of those aircraft drops don't put out the fire. That's not their intent. They're mostly used to delay the fire spread and to reduce its intensity so that people on the ground can get some work done. And lastly, just want to point out this job it's hard work, it's dirty, and it's dangerous. Next. Now, there's an area that's growing in this country called the wildland-urban interface. It's the area between the forests and the cities. A lot of people are moving out into this area, and it makes firefighting really hard. It's challenging because a lot of people aren't really aware of the risks that they're accepting by living out there, and it makes firefighting and fire suppression a lot more difficult. Next. Okay. So a lot of that stuff's kind of high level, but now I want to take you out to a fire that was burning last year in Northern California. It was a fire I was on. It wasn't particularly big. It wasn't the most expensive fire or anything, but it was interesting to me for a number of reasons. And what I want you to check out first is the map on the right there. You can see the perimeter of the fire. Most of that perimeter is black. That means it's contained. There's a couple of little sections down at the south and over in the west where the line's still open and uncontained. But for the most part, this fire looks like it's pretty well buttoned up. But on September 6th, there was a severe wind event that came out of the south that pressured the containment line over on that east side. Fire blew out on it. And resources responded, both from the air, ground, and I overheard some interesting traffic on the radio. And the firefighter in charge on the ground and the firefighter in the air, they couldn't agree on where to put the retardant. They went back and forth on the radio. And meanwhile, the tankers were orbiting. And they were looking at the same fire, but they were seeing it differently from different perspectives. And ultimately, the fire, the retardant was put in, but those two guys could never really agree on where to put it. Next. So the following day, I took this picture looking back to the west, and that's what that little chunk of fire that blew out yesterday looked like the following day. Now, that area of fire was about 1,500 acres, and the main fire was about 70,000 acres. So it was relatively small, but just to give you some perspective, inside that little red circle is what we call a large air tanker setting up to make a retardant drop. 3,000 gallon capacity, it's about 86 feet long. And that thing's dwarfed by the size of that column. Next. Okay, so a couple days later on the 10th, something else interesting happened. By now the fire's doubled in size and it's still running. And in the early morning hours of the 10th, there was a task force working night shift, and they were operating up in that red circle there. And the fire behavior was very active, and they needed to pull out of the area. And while they were escaping, one firefighter did get injured with some minor burns to his hand and his ear. Next. And this fire in this incident was really interesting to me because it raised three big questions. Where was the best place for that retardant to be put down on the 6th? Was there any way for the night shift to know what they were up against that night? And then lastly, were we really all that effective out there? Sam.
Thanks, Hans. So because wildfires are exponentially growing in their damage and cost, and firefighters do not have the adequate resources to do their jobs to the best of their ability, we developed the project concept of WSpER, which is the Wildfire Suppression Experience Reactivation System. And our vision is to empower firefighters to make data-informed decisions to reduce risk and maximize resource efficiency. Next slide. So with this vision in mind, we analyzed the opportunity to address ineffective wildfire suppression. Right now, there is limited information and baseline metrics on what suppression is effective and which is not. Right now, what we know is that at least 5.4% of suppression costs are ineffective due to ineffective aviation suppression. As Hans mentioned, there is further research indicating that this metric could be significantly increased based on further analysis on aircraft fire spread delay tactics. As you can see, the ineffective ground suppression cost is unknown, but provides further opportunity for this project to have further cost savings. And overall, total suppression costs are increasing at an average of 20% annually. So knowing what we know now, this opportunity in our project has a net present value of $2.6 billion and can establish baselines for ineffective suppression costs overall. To give an example of what this might look like, if we were 5% more effective in 2021, that would have resulted in $22 million in cost savings. So our plan, based on this limited knowledge, will be to reevaluate this analysis and opportunity down the line as we establish more concrete baselines. So with this vision and opportunity in mind, we conducted a business analysis of the fire service that I will pass to Ken to explain.
To support wildfire suppression via WSpER, we analyzed the business using business context evaluation frameworks, and we engaged stakeholders. We utilized top analysis, strategy, diamond model, Porter's 5 forces, ESE profiler, and SWOT analysis for this effort. On the right, we see a SWOT analysis, which identified that there would be a public support, but internally, the buy-in along with system integration would be difficult to achieve. Key takeaways from the other frameworks include WSpER being a new capability for the fire service, and thus it won't have any competitors in this industry. And multiple problems were identified and sorted by weight and feasibility to mitigate. The key barriers and challenges for WSpER include system integration complexity due to the fire service processes being fragmented and not set up for continuous learning, and firefighter opposition to adoption. With that being said, the model on the left illustrates the stakeholders, which were classified into groups so that particular attention can be paid to their respective concerns. However, unbiased stakeholder feedback was difficult to secure. Many stakeholders were contacted, to which most were unwilling to participate. We tried various approaches, including providing surveys to the stakeholders as a means of engaging their interests. The business analysis thus supports the business model. Next slide. Which can be summarized with 4 key points: the who, the what, how, and why. WSpER would operate under the fire service. And the suppliers are the federal decision makers responsible for awarding funds and affecting policy. And the customers are the taxpayers and the stakeholders. As for the what, WSpER is a decision support tool, which provides the probability of success. The system collects and stores wildfire-related data and digitized firefighting experience, then leverages machine learning to calculate and provide probability of success. The key takeaway from the what and the how key points is that the probability of success is the value that WSpER is generating. As for the why, wildfire suppression requires improved decision-making. WSpER offers data-informed firefighting, optimized resource deployment, and a firefighter learning database. I will now turn it over to Hussam for the WSpER solution.
Thank you, Ken. WSpER solution. WSpER solution will include 5 aspects, starting from the data integration, via collecting and digitalizing the wildfire fighters' previous experience and combine it with the ongoing experience. As of the users the wildfire fighters, the aircrafts on the field, they're going to keep feeding back to WSpER to update that data. Aside of that, WSpER will work on combining multiple inventories from different resources, partners, and support and suppliers into one centralized inventory. What are we going to do with that data? That data is going to be stored in a database aside with weather forecast and topography from the wildfire locations. All these information will work together to generate a simulation. That simulation will lead us to provide the probability of success that help the wildfire fighters in the field to make accurate decisions in a short time. How we vision WSpER and how we can use WSpER. WSpER will provide us with a continuous status of the wildfire according to the information that's collected from wildfires, aircrafts, wind speed, directions, topography, temperature. All these is going to be worked together, as I say, to generate the probability of success. Probability of success. In our example, in our use case here, we see there is like two fire lines. First fire line, it's going to take us up to 16 hours to build it, but the probability of that success is going to be 36%. On the other hand, we have another fire line that is 24 hours to build, 81%. Harder work, more possibility to suppress the fire. A lot of people will say like, okay, yeah, 81%, that's a win, let's do it. Someone else will back to say, okay, by default, the farthest that we can go from the fire, build the fire line in there, we can, we will have a better probability of success. No, the answer is not that. As we can see here, this is a different scenario. From fire, could be there's a different scenario. The scenario here is saying the fire line 1, still 16 hours, but it have a probability of success of 85%. And fire line 2, it's a high risk. What can be the high risk? There's multiple reasons for the high risk. It could be the area between fire line 1 and fire line 2 contain a type of fuel that it's hard to control. It could be the topography of that area. It's hard for the wildfire fighters and their equipment to access to build that fire line. So we can see how WSpER will work together with the location itself, the weather from the location, the previous experience, and the current experience, and all the data that is collected into our database. How is the probability of success going to be generated? I will hand that to Oday.
Thanks, Hassan. Thanks for detailing that. Hello, everyone. Good afternoon. So as Hassan described, there are like two important aspects to this project. So one is like a user experience, firefighter experiences, collecting the data, and then helping run, get the probability of success via like a AI and ML model, correct? Let's talk about like how like we can capture the experiences at the incident site. So as the firefighters finish the their shift and then come to the like a site, so they're given a, like they have a devices based on their experiences. Basically, like they will log in and then they will input their experiences, which are like given in like short form of like a choices given, and then they will select the data, and then that is fed into the system. Along with that, important aspect is the GPS locations and then the GPS tagging. So the path they travel through to develop a fire line or to have the suppression of the fire, that data is also collected and then fed into the system. So that's the first aspect. So we are building the history of like their experiences along with the path they traveled, and then like how they experience the fire in a particular location. So this data would help like establishing like similar fighting the similar fires at a different location with the same topography or weather conditions and topography. So now let's come back to the second important aspect where we are going to generate the probability of success. So how are we going to generate the probability of success? Imagine a scenario like where the incident commander is sitting at a mountain hill in Northern California, and then he's trying to establish fire lines, Hassan showed, like there are 2 or 3 fire lines, but he may not have enough resources, and then he doesn't have enough data available to make this decision where he can send the firefighters to fight the suppress the fire. So as like a incident commander inputs the data, so we have the GPS location at that particular location, and we have the resources that are already assigned to the site. So we have all the information. When he inputs to the system, so this data is collected by like API and then like sent to like an event bridge where the data is forwarded to the AI and ML inferencing. So why we are sending it to the event bridge? Because the AI and ML would take time to compute. So we can't respond back in a synchronous way. So we have to respond it back like in a push notification back to the incident command. So now let's talk about how the AI and ML model is built. So AI and ML model interacts with like multiple databases, as like Hassan mentioned. So this first one is like important one is the experiences. So which gives the historical data of like a similar topography and similar weather conditions, and then similar fuel types. So the second one is like a Wi-Fi fire modeling system. So we integrate with fire modeling system, and then we establish like how the fire propagation happens like a period of time, like maybe like next 24 hours, and then that will give us a picture how much like how we can suppress the fire, and then like where we can establish fire line. Second one is the logistics, like do we have all the supplies necessary to suppress this fire or like delay the fire? So including the aviation material, it could be like whatever the access and pickle and everything. So third one is the skills and resources. So skills and resources are stored in the resources database. So do we have enough resources with the similar skill set that we require, or are they available in the nearby location? So based on this, like it will compute, and then this model is prepared and then push it back to inference engine, which is like a production-based inference engine. Once the compute happens, so it will push it back to the incident command. So pretty much like this is done everything in the cloud. So it's very much optimized, and it's used only like when the resources are required. So the top layer describes the service layer, which is like a microservices layer utilized for the experiences and other stuff, or like finding out like whether we have enough resources, whether we have like enough logistics, everything. The second one is the AI and ML model. So next slide. So we have developed like an excellent application, like which can provide the information that's required for the incident commander. But having no security or having minimal security, it wouldn't help. So WSpER being like an application that's like mainly like a government entity based application, there are like bad actors always try to compromise the application and breach the application. So there would be international actor or like actors that maybe within the US continent, they may be trying to compromise that. But we want to secure this one. So if you look at the history, so a data breach costs like an average of like $4.35 million, an average data breach based on the IBM study. So the recent data breach like a T-Mobile, it was $500 million, and Equifax, it was $2 billion. How we are going to secure? So there are like various aspects. AWS itself gives like the security, infrastructure security. Basically, it's like a physical layer, and then at the end of the day, you don't have visibility to their data centers. So the network security is given by like a VPC and firewalls, and then there are like tools like AWS Inspector, Data Guard, Guard Duty, and then AWS WAF. So it's a firewall protection. So these tools will help you to protect the resources that are important to you, the WSpER application. So the third one is the most important one, is the application layer security. So API is like secured by like OAuth and then certificates, and the container, which is like another important, because we have like a lot of microservices. These containers need to be protected because nowadays, like you use a lot of libraries, and these libraries can be compromised with the malware. So how do you detect that? With the there are like tools like Anchor tools, and then like a Microsoft GitHub. They can detect the compromisation of these libraries and help you to avoid that. Along with that, so you have like an encryption layer, like a transportation layer encryption, and then identity and access is another important layer where you secure with the Azure AD and then with the AWS Cognito pool. So now we have secured this one. So let's see how it would benefit the public and then the US Forest Services. I will hand it over to Diane.
Good afternoon, everyone. I hope everyone have a good lunch. As you can see, all the problem with the wildfires, we have a solution, the business and the security for our system. And now I will summarize the key benefits for our project. We can reduce the cost. As you can see earlier slide, in 10 years, our net present value show that we can save about $2.6 billion. We can reduce the cost for life and property. By using probability of success metric based on our available resource, the fire spread potential, and historical success rate to help firefighters perform their tasks effectively. We can protect natural resource by using simulation model, which would display the sensitive resource area and fire light location. Our tool can also improve forecasting by telling the firefighter location where the weather is more likely to cause the fire. Our system will improve the decision-making process by using decision support system to help stakeholders make the right decision. All of this can help firefighters know where to go perform the task more effectively. Next. For roadmap, year 1 and 2, we will engage the stakeholder to develop existing data sets with probability of success based on data coming from resource and fire spread potential. In year 3 and 5, we will enhancement, update, deploy the system across California. In year 6 and 10, we will expand the system across the United States and other countries. Next, please. In summary, for the problem, wildfires cause so much damage to people, cost a lot of money for the government, is keep increasing. We have the solution by providing the probability of success matrix to optimize the resource and improve the decision making will help reduce the cost and protect life and property. For business, our system will reduce the cost 5% in 10 years. We save $2.6 billion in net values, present values. Next step, we will secure funding to establish stakeholder group. We also plan to expand the system from California to the rest of the United States and other countries. So as you see in the picture, the firefighter location will provide the data. We will use that data to run the simulation. In here, we will calculate the percentage of success of the fire line and then generate the probability of success. Then provide this data to firefighter through the user interface and the app. Then a firefighter will use that data to go to the fire location. With that, we'll end with our presentation. I would like to thank you so much for all professors taught me in the last past year. I learned a lot in the short period of time. And also thank you everyone for listening today. And now we will open up for the question and the comments.
Thank you, Team Fire. We're open for comments, so raise hand and we'll call on you. Who would like to go first? Professor Zach?
Yes, thank you very much for the presentation. I have a question about stakeholder engagement. As I understood it, it was a challenge getting stakeholders engaged early on. And that's unfortunate, it happens. And then on the last slide, you are saying that you would like to get funding and start with stakeholder engagement. I'm a little worried about the horse and the cart business here. What was the root cause as you see it that people didn't want to give you the time of the day?
Yeah, Professor Zach, the stakeholder engagement was a big problem for us. We went into this project expecting to target a certain group of stakeholders, folks that we knew or that I knew basically, but then we really tried to mitigate bias. So we tried to reach out, I tried to reach out to folks in the community that I didn't know and they didn't know me. And there was a lot of reluctance. I think a lot of it was just not knowing me and a lack of trust. But yeah, we tried to target a wide swath of folks because the fire service it encompasses a big community. So I tried reaching out to folks not only at the federal level but at the state, county, city levels as well. And yeah, it was pretty consistent. Nobody really wanted to talk. We did get a couple of responses though, and those responses were consistent with our approach, which was encouraging.
My concern is that having something ready-made, even if you had all the funding you could wish for, and you would start developing something, then going to those same stakeholders and saying, well, you didn't want to talk to us before, but now we've built a system. Would you like to see how it works? They would likely continue being reluctant. So I would encourage you to find, if you were interested in pursuing this, to find new ways, working ways, to engage with stakeholders before you spend money.
Copy that. Thank you.
Next questions? Well, okay. Then I get to ask the questions. Oh, Professor Romer.
All right. So thought I would ask a question here. So I don't understand exactly how you get from the data to the probability model. You mentioned machine learning. I assume there is some magic going on there, and assuming that's the case, yeah. And I saw and you went through this. I mean, I simply don't understand enough about this to assess it. But what would, suppose this is successful, you can do this in California. You probably gather input data about terrain. You gather input data about general fire and firefighting. Why would it take you, once this is successfully demonstrated in California, why would it take you 3 more years to bring that to the rest of the world? Because once you have the algorithm, gathering the data shouldn't be too complicated. Once you know how fires work, they work similarly all over the world, just the territory is different. What is the 3 years that you would need?
Hans, you want to answer?
I think the main problem would be getting different players on board, because that fire service, the community, it's not homogeneous. There's a lot of different jurisdictions and a lot of different players and a lot of different folks. They have their own preferences, and I think it takes time for something to really spread throughout such a wide community. So I wouldn't expect the adoption to be immediate, the scaling to be immediate.
So
I would say
it's an adoption problem rather than a technical problem. Then that definitely answers the question. At the same time, I would say if you demonstrate in one fire successfully that this made a difference, I would imagine that all of a sudden you have lots of stakeholders that want to engage with you, right?
I can see that as well. Thank you, Professor.
So question in terms of champions, are there any champions in the fire service, who are looking at data analytics? There's certainly people fighting fires, in urban areas who are starting to look at data analytics and that sort of thing. Is it possible to enlist some of their support in this space?
I would say definitely. So first off, yeah, I do think that there are champions and there are initiatives out there where folks in the community are really trying to lean into the issue and be progressive. I think we've made some huge strides with wildfire modeling. And I think that folks are always trying to find better methods, better equipment to employ out on fires. But I think one of the big hurdles that we face is that we're trying to step into a new space. No one's really in this space. You see, there's a lot that we can measure about fire suppression resources and how much money we spend and how many miles of fire line we put in. And there's a lot that we know on the other side about what a wildfire is capable of, what's likely to burn from it, but it's the space in between those two. That space is the firefighting. And we haven't yet been able to successfully connect, the effort with the wildfire potential. And if we can connect that with something that's measurable, a metric, then we think that we could really be effective at fighting better fires. If we're trying to moneyball wildland firefighting, you need numbers to do it. And for us, that foundational metric is a probability of success, and that just doesn't exist. And a lot of people right there, right now, they don't know what to look for.
So I'll continue to ask questions. Would it be possible to create a firefighting game that would get firefighters to be interested so that they could play the game and see where their instincts might not be right, and then get feedback to see what would actually happen and say, hey, this happened, it wasn't exactly the same, so on and so forth. And that might get them interested. Sort of playing the game might sort of build some confidence and not be as threatening.
I think absolutely. I think that there's a huge potential to apply some gamification to the training aspect of wildland firefighting. And like you're saying, help people dip their toes into this this new concept and this new way of fighting fire.
Well, actually, we talked about that, like in the team, about how we can use this technology or using WSpER in training. So the idea of having a game, it's really brilliant. Thank you so much for for the idea.
Well, sure. Yeah, it won't affect your grade, but you've got 2 days. You can write it in, at the end of Sunday. I got a comment here. This is it says, Dr. Zach, there was a cool term you used for technology being used in an unintended fashion and the organic outcome of that dynamic. I've been trying to remember it for 8 years now. Does that ring bells?
Hey, I'm sorry, that was meant for Dr. Zach. I didn't mean to interrupt your presentation. It's just the first time I've had a chance to talk to him in 8 years.
Okay, I didn't know if that was related to the presentation, but
it's not. I apologize.
Oh, okay. So let's see. As a firefighter, how do you imagine using this tool? Is it something that you can? You can sort of, when it's in its right or when it's not. How do you sort of liken the game? Because as someone who doesn't fight fires, I have no idea what the environment's like, how much time you have to make decisions, and those sorts of things. Is it a game of seconds, minutes, hours?
I think for tactical decision making, you don't always have a lot of time. Seconds or minutes really. And I think that, you know, to borrow a chess analogy, I think that you can recall Kasparov and the supercomputer and how eventually this supercomputer won. And it did it by collecting and processing, you know, a lot of just normal chess moves from a huge audience. And I think that if we can do something similar, if we can capture and process and make available a lot of decisions that are being made out on wildfires, then we can present them back to future firefighters in a way where they can utilize that information and essentially expedite the learning curve for them. You know, they could potentially be making expert decisions with this tool. You know, instead of having to gain 20, 30 years of experience, they could work with this technology and realize better outcomes sooner.
So there was a comment by Tomas asking the question, you know, do you have data sort of with respect to extending this model to being a game of chess? Is that an analogy that actually works?
Maybe I can elaborate. Initially,
Yes,
when I heard this, I imagined some kind of deep learning where we have hundreds or thousands, well, thousands and 10,000s of fire pictures and firefightings, and we put some deep learning on this. But I cannot imagine that we have that much of footage of fires and how they were fought that we would come up with something. But then you went into simulation and simulating fires. And again, this is a world that I don't understand at all. I've never thought about that. I find it fascinating, but is there enough data to come up with something that is rigorous?
I don't know of streams of data currently that would be sufficient. I think that there's new streams of data constantly coming online. I know there's the Dingle Act came down not too long ago, mandating the adoption of certain tracking devices. I think that could produce a lot of data that could be used. I also think that as we start looking into this space, and once we start finding stuff that we didn't know about firefighting, that would pique people's curiosity and help drive more data streams. I think machine learning, machine intelligence would be a critical component of this entire thing. I think, as I believe you were alluding to, the deep learning aspect would be critical, I think. I also think that there's the potential to use classification and regression in some interesting ways as well.
I mean, there's the simulations of what the fire can do, but then there's also data on what humans can do. So if you say we need to build a fire line like this, then it probably needs to be a certain depth. There's also characteristics of the land in which it's going to be built. And if you have enough data in the past, you can sort of say it's likely to take this many people this long to do it. And if you've got inadequate resources, this sort of thing could show you don't have the time to do what you're trying to do, given the dynamics of the fire that you're fighting. You need to come up with a different solution, or you need to apply more resources. And I think that's a place where simulation and lots of data can help you estimate things much more quickly than a firefighter making tactical decisions when all hell's breaking loose, which is probably the case. So it would seem like there's those sorts of things that you'd be able to get feedback on quite quickly. As you know, players of chess, like a team of people who are average players with laptops can beat Kasparov, and they can beat Deep Blue as well. You need to get into that kind of gamification where you can do the what if situations, and the firefighters are used to asking those questions quickly and coming up with different scenarios really quickly. And I think in that case, I think you can greatly increase their capabilities. And you could also get some buy-in, because if they find that they're able to do things with the tools that they can't do on their own, and they're more effective, then they will tend, I think, to embrace those capabilities.
I agree. Thank you.
There was some feedback from Keith. He says the other piece you did not seem to look at is to connect an array of low-cost sensors, heat, LiDAR, small drones, video, that begins to integrate and fuse data, which is where AI and machine learning really shines. I don't know if Keith, if you wanted to say anything more about that before we close this session. Any comments from the team?
Yeah, I said like that's a good suggestion to be included, part of the aviation. We can collect the data and then we can include in the model. Yeah.
Professor Kruger, I see a hand up.
Yeah, so just a comment, stay encouraged about this project, because 30 years ago, people were working on the first set of expert systems, as it was called back then, for diagnosing disease. And today, some of these systems are outperforming well-trained physicians in doing so, through image analysis, through a variety of other data sources that they can tap into. And you just have to make a start. So make a start on this and stay encouraged about this project.
Thank you, Professor. Appreciate that.
That's a great way to sort of cap off the session. Thank you to the team. Thanks for the presentation, and thanks for everyone who listened and gave the great questions. And as someone who lives in California now, please do proceed with this project. It's very important to us all. So we will take a break now, and we will start at the top of the hour.
Thank you all.
Thank you, Professor Wade. That was kind of like a satellite for launch countdown right there, from 5 to 1 to now. So appreciate that. Hello, everyone. I'd like to introduce the Viasat team to you all. Jason Bernberg from Global Security, Andrew Giles from Government Services, and Robbie Araveni from Global Technology. And I am David Rawlingson, also from Global Technology. Let's start off with a backstory. My role at Viasat is the Payments Platform Manager. I'm responsible for the quality and security of payment processing at Viasat. So this includes making sure that the platform is PCI compliant and adhering to Viasat's foundational security principles. If Viasat were to fall out of compliance or a security incident occurred, in both scenarios, it could impact hundreds of millions of dollars in payment processing, affecting my job and other Viasat employees, not to mention the horrible experience for our subscribers. So on a regular basis, I'm working closely with our compliance and security teams to make sure that Viasat isn't the next company in the evening news. If I were to ask from the audience for a raise of hands, you don't have to raise your hands, but of those that have been impacted personally by a cyber incident, sadly, I believe most hands would be raised. So when the team decided to take on the Gatekeeper project, which is the digitizing of data policy and access automation to maintain compliance while increasing Viasat security vigilance, needless to say, I had a vested interest, and I know our customers will too. These customers are Viasat data source owners, data consumers, and teams such as security, legal, and compliance. I'd like to focus your attention to the problem statement section in the top left-hand corner. These high-level items are what our stakeholders have called out. Security teams are worried about a data leakage, which will financially affect Viasat, shrinking revenue and diminishing the value of the company brand. Our legal and compliance teams are concerned about evolving regulatory requirements that lead them scrambling to keep up with the changing times, working to mitigate the risk of falling out of compliance. Data security has not been prioritized enough as we grow globally, putting Viasat at risk due to the increase in worldwide threats. This needs the attention of every data consumer and every data source owner at Viasat. During our project journey, we became aware that as Viasat expands globally, there's been an increase in a diversity of data security challenges. I will quickly walk all of us through how Viasat is growing globally to provide more context about these challenges. With these images, you can see the global expansion over the years, starting with Anik F2, the satellite on the left, which is the first satellite in the fleet. The blue area demonstrates connectivity coverage, and as the years have gone by, Viasat has increased its coverage area, as shown with the launch of Viasat 2 in the center. But that blue coverage area will have a drastic change with Viasat 3, as represented with the image on the right. Viasat 3, our newest satellite constellation, which will consist of 3 satellites over the next few years. Once all 3 have launched, they will provide a majority coverage of the Earth, helping us to achieve our company mission of being a global internet service provider. The first of the 3 satellites is targeted to launch at the end of this year, with a goal of 1+ terabytes per second, expected to be 3 to 4 times more cost efficient than Viasat 2. Global expansion by technology advancements alone is not the only method Viasat is using to achieve its mission. Viasat is in the process of combining with Inmarsat, a satellite ISP in Europe. Once the acquisition is finalized, it will create a global ISP innovator, as said by Viasat CEO Mark Dankberg. As Viasat grows into more countries, this will increase the regulatory requirements on Viasat, the complexity of our enterprise architecture grows, employee count rises across the continents, our global customer base will grow exponentially, and the Viasat brand will become more well-known. Each of these items can increase the risk level of a cyber incident, along with inefficiencies in incident triage or resolution, and the potential of falling out of compliance. As you can see, the past 20+ years, Viasat has been revolutionizing the satellite industry and working to become a global ISP. We are known for our technological advancements. What we don't want to be known for is one major incident. Sadly, the next security threat is always around the corner. Here are some recent incidents of 2022. A former Amazon employee impacted Capital One and 30+ other companies, stealing 100 million customers' data. A hacker at QuestionPro stole personal information, conducted extortion, and pulled off attacks on the FBI. A hacker caused Neopet's data breach, posted 69 million customers' data to an online forum, also exposing Neopet's source code. We also need to talk about the internal threats, which can be both malicious as well as unintentional. Can you tell who the threat is in these images? Is it even any of these employees? How would you find out the who, the what, the when, the where in order to mitigate the risk? So far, these examples have been external and internal cyber incidents that lead to a data breach. Let's now look at the problem from a non-compliant impact scenario. Here are some high-level details regarding what could happen to a company if found PCI non-compliant. For non-compliance, monthly fines will be levied until an organization is back in compliance. An organization could be sued for a hefty sum, including the cost for legal fees, and forced to deal with the fallout of the negative PR for a public lawsuit. And lastly, a company may no longer be able to conduct payment processing, causing revenue loss and damaging the reputation of the company brand. Now that you have heard who our customers are, their problem statement, and the outcome of those items, if not mitigated, I have one last topic to share. Some can view it as the impact to the success of Gatekeeper, but our team saw it as an opportunity. While meeting with stakeholders, we became aware of a new company initiative to establish data governance along with implementing enterprise architecture changes. Parts of this larger effort could have been seen as duplicative or in contrast to Gatekeeper. There are a few items that are being focused on: information asset management, enabling a hyper-connected enterprise, federated data governance, and delivering insights to the business. Instead of a competing effort, our team saw a lot of synergies with this initiative and thought it best to get involved, partnering with the leadership, collaborating on where Gatekeeper can further improve regulatory compliance, secure data, and add additional system efficiencies as part of the larger effort. The plan will be to continue this partnership and focus on bringing to the forefront our stakeholders' use cases. With Gatekeeper, Viasat can also achieve the impossible in security, compliance, and data access. To discuss the details of our operational concept, use cases, and our partnership with the Data Governance Initiative, I'll be handing off the presentation to Jason.
Thank you. David walked through all the amazing and scary things that can happen to Viasat. The big question that I'm sure many of you have, and the one that we sought to answer, is how do we prevent all of these issues? The answer is actually pretty straightforward. Protect Viasat's greatest asset, its data. The goal of our system is to ensure only the right data consumers can access our data. We also want to have confidence that the wrong people cannot access our data. We establish this confidence with consistent policy application and visibility. To add some color and really understand where we can insert security, we documented how the system might be used and what external forces cause the system to change. To really show the problem we are trying to solve, let's see in today's world how David deals with each of these use cases. To start, David or someone on his team has to review all access requests and ask the requester follow-up questions to understand who they are and why they need the data. Since David's team is trying to meet PCI compliance, they are thorough, and this takes multiple back and forth questions. Now, once approval has been granted, that user has to read through API documentation and understand how to authenticate to and interact with that API. Now, what happens if a regulatory body updates its requirements, say establishing PCI 4.0? David's team is responsible for researching and implementing the changes required. Similarly, what happens when Viasat expands to a new region? David's team again has to research and understand the changes they have to make to their systems. On top of all that work, every year David's team is audited for PCI compliance. To make this not a crazy rush for his team, they have to maintain documents and product features to ensure the audit goes smoothly. There are many teams at Viasat like David's, and many more compliance requirements than just PCI, such as CMMC, ISO, and SOX. In order for our system to work, we have to handle onboarding all of these data sources and data types. Now, what happens when things go wrong? In our current system, every data owner has to make sure their system logs are being sent to security, and our security team struggles to understand all the unique and different log formats. To address these issues, in Gatekeeper, we have common access management and data integration systems. So all data access logs are collected into a single spot. We won't have to hope or guess if the security team has enough context. They will get all the logs by default and in a standardized format. With the single system, they'll be able to easily investigate the security incident. Now let's look at how David's world changes with the Gatekeeper system. First, to use our system, David must onboard his data source. During this onboarding, he will note that his data contains payment information and that it is under PCI compliance. After our data operations team verifies and approves that the classification was completed correctly, users can now request access to that data via the data catalog. The request will still go to David and his team for approval, but the request will come in a standard format with all of the required information added, plus being enhanced with information about the requester. All of this will make for less back and forth and a quicker approval. After a requester has been granted access, they can go to a single unified set of APIs with a consistent authentication method to access that data. While there will always be a need to have some requests, this system adds a component of identity governance, which will allow for birthright access, which means just by the nature of a user's role and what team they are on, they will be granted access to data, removing the need to go through that request process altogether. This system also increases security by having the ability to know that someone has changed teams or roles and can remove that access. Now let's get back to the other challenges David's team faced. Instead of his team having to understand each new control or new region's laws, our system has a policy management committee and policy management service. This committee will research all the changes and define policies within the policy management system, creating a central location for all policies, allowing David's team to only focus on what has to change. Last, for the hassle of audits, Gatekeeper will have a central logging and access management system that handles creating all reports, saving time for data owners. Let's move on to how we can take this logical design into reality. Throughout this project, it has been very clear to us that at Viasat, no idea is a unique one, and almost every component is being designed, purchased, or already exists. One of the best examples of this was the data governance effort that David had mentioned, which started picking up steam around the time we started our master's program. It is looking at solutions to solve our data catalog and data source integration components. All of this means that we spent significant effort evaluating requirements and capabilities of other systems to ensure they work with it in our system. This list of components here is not finalized, as many are still in the request for proposal stage, but they are our leading candidate solutions. Note that for data catalog and policy management, a single product, Calibra, actually filled both roles. Next, we looked at how each component would be deployed. Since many of the components of our system are being deployed by other teams at Viasat, the deployment location varies. At Viasat, we have a multi-cloud environment and explicitly chose not to stick with a single cloud provider. Deployment locations are selected to be most cost-effective, which is impacted by many factors around people and technology. This is the case with Visium, our log aggregation and analytics tool, which was deployed to AWS 2 years ago, making it cost-effective to keep it there. Now that I've shown how the system will work and what we have to build, Andrew will go through how much this all costs and what the financial benefits are.
Thanks, Jason. By solving David's compliance problems and reducing the risk of security threats to Viasat, Gatekeeper can potentially save hundreds of millions of dollars. However, as we began to analyze the value delivered by Gatekeeper, we discovered that the degree to which the enterprise adopted the system was a key driver in uncertainty. Mitigating risk, scalability, and cost reduction, each of these depends at some level on the degree of adoption enterprise-wide. At low levels of adoption, the value can be mere tens of millions. At high levels, Gatekeeper could save hundreds of millions. And so we started to look into how we could reduce the risk of a low level of adoption. The major challenge of our project is not a technical one. Viasat is full of talented, capable, and motivated people who do the impossible every single day. Instead, the biggest risk we face is performing a major cultural shift. Viasat's current data governance model came from organic growth. It wasn't planned or deliberately architected. It's the result of individual projects and teams picking technologies and procedures they believe balance the competing needs of data availability and security. This has resulted in many unique data handling systems, each with their own quirks and skill sets needed for operation. This is really inefficient. It makes it more difficult to transition engineers between projects and promote siloing data instead of sharing it. Changing employees' minds from "I know what's best for my data" to a federated model of "you have the best practices that I should follow" is a risky proposition. And so we looked into how we potentially reduce this risk and help drive Gatekeeper's value up. We investigated changing our deployment plans to perform a slower rollout, allowing for more time to collect feedback and make adjustments to our messaging and stakeholder engagement. Our original deployment plan was to scale to the entire enterprise as fast as possible. In theory, this could deliver the most value in the least amount of time. However, given the risks, We think this is more likely to end with most of Viasat refusing to use Gatekeeper, and consequently a low return on investment. The alternative option is to create a 2-year pilot that will include an end-to-end build-out to a single business area. This will allow an instance of each core infrastructure component to be set up, integrated, and tested. By measuring and tracking outcomes, this option should prove that the architecture can work on a smaller scale. It will also highlight any unforeseen issues, help validate costs, and provide data to use to adjust the rollout plans for the rest of the company. In this risk reduction approach, at each of these major decision points, we evaluate our measures of performance and determine if it's appropriate to continue to expand Gatekeeper score and adjust our approach to maximize the potential of success. Fast deployment plan lacks these decision and adjustment points, and we believe it will track closer to our lower estimates of value, 22 million. Given the uncertainties involved, we think the slower rollout will effectively mitigate the risk of project failure and instead have a value somewhere between 76 million and our maximum estimate of 553 million within the green region on this slide. To estimate the value generated by Gatekeeper, we considered several factors. It makes it easier to find data and request access, and leveraging identity governance removes several human steps in the existing approval process. And faster approvals mean increased employee efficiency. Centralized management makes fulfilling audit and other compliance obligations much easier and enables scaling to a globally connected enterprise. But most importantly, consistent data governance policies reduce the risk of data breaches and fines. This is by far the largest source of value by safeguarding Viasat's data and keeping us out of the news. For an initial deployment, we require 8.5 million for the first 2 years. This will allow us to deploy systems and onboard a single business area, further allowing us to fine-tune our approach for risk reduction around deploying the system company-wide and promote buy-in from the other business areas. Fully funded, Gate requires 28 million over 6 years to roll out the system to the entire enterprise. These funds pay for several major line items. We'll need to license the appropriate software systems, deploy and maintain those systems, as well as spend some time developing digital policies and integrating data stores. We estimate software system costs of approximately 3.7 million per year, which includes about 2.5 million per year for maintenance and operations. Additionally, we will expect it will require about 1 million per business area to onboard their data stores into Gatekeeper and create digitized policies. Now, this initial pilot has a negative return on investment, negative $1.1 million. But if we treat it as enabling a high volatility option, we can get a sense of how our uncertainty impacts the potential value. Right now, the option to deploy Gatekeeper to a second business area is valued at 3.7 million. This is greater than our initial loss, so we feel confident it's worth it to go ahead with the 2-year pilot. And ideally, as we mitigate our risks and uncertainties, our expected returns will grow towards our maximum estimates. And we can reevaluate our financial positions at any point throughout the project. If circumstances change and the pilot fails to live up to its potential, these changes will be reflected in the option value and our expected returns. And we can determine at each phase if it's worth continuing to deploy Gatekeeper. Now, I'd like to hand over to Ravi, who will walk through the roadmap in a little more detail.
Thank you, Andrew. Thank you, everyone. For the financial walkthrough, given the complexity, it is not advisable to implement the project without a proof of concept, as it involves integrating with multiple components and challenging Viasat's culture norms. We divide the project into 3 horizons, and each horizon will include multiple phases. The horizon first will last for 2 years, and we'll have 3 phases, starting with a proof of concept, ending with a deploying into our most receptive business area. Horizon 2 lasts 1 year and will expand into one of our more difficult business areas. Horizon 3 deploys in the rest of the enterprise and also into our pending Inmarsat acquisition. We expect the initial investment of $8.5 million to fund the first horizon, at which point we can decide if you want to continue funding Horizon 2. Let's dive into the bit details of Horizon 1. The three phases of Horizon 1 are proof of concept and then phases 1 and 2. During the proof of concept, we will deploy our core capabilities and connect to a single data source. The goals of this phase are to validate our costing and value estimators, test our core infrastructure, such as policy enforcement, data source integration, and using identity management for access controls. During phase 1, we'll expand from a single data source to an entire business area. We will be careful to select business area that is already to support our system and will be easy to deploy to. This phase will be focused on delivering some of the major functionality required to scale Gatekeeper, specifically our capabilities around onboarding and classification of data sources. We will also focus on crafting policies to meet our compliance and regulatory requirements. The last phase of this horizon is focused on measuring, evaluating, and improving the system. We will spend 6 months gathering data with our system deployed into a single business area in order to optimize our processes and fill in any usability gaps before expanding to a second business area. At the end of this phase, we will have to make the decision if we would continue funding the system. In order to measure the success of our system and help determine if we should continue funding the project, we have defined some measures of performance and what values of those measures mean the system is effective. Our system is trying to ensure we do not have a data breach. To that end, we have defined 2 measures: number of non-compliance events and number of days a vulnerability is open. To ensure the system is not the cause of the next data breach. Next, in order for a system to be inserted and used as a critical piece of infrastructure, we will measure our system availability. Lastly, to ensure our system is delivering its core capability successfully, we define 3 measures: number of access requests, average time to approve requests, and time to update a policy. Each of these measures will provide valuable data that can be used in our NPV and ROV estimation. This will enable us at the end of Horizon 1 to decide if we should fund Horizon 2. During each phase, these measures will have to be adjusted and sometimes even new measures added. This will enable us to use these measures as our definition of success and as a trigger to change the system. The second horizon takes any lessons learned from the first horizon and incorporates necessary changes to the architecture. Once it's understood how Viasat culture reacts to the platform, we can adjust our user engagement accordingly. In year 3, we select a second business area to expand to and deploy Gatekeeper with the latest changes. We will select one of the more difficult business areas at Viasat to learn as much as possible before expanding to the entire enterprise. At the end of Horizon 2, we will have the ability to make another decision around funding Horizon 3. We'll approach this decision the same way as the previous by using our MOPs. Finally, in the third horizon of Gatekeeper, we roll out the Gatekeeper system to all of Viasat. This enables identity governance for all business areas and data sources and delivers on the full vision of what Gatekeeper can be. This horizon will have many phases in order to expand to each remaining business area, eventually into an Inmarsat acquisition. This horizon leverages all of the feedback gathered from the first 2 horizons, and our system will continue to evolve through each phase. Data breaches have been significantly issued for many organizations to build trust with the consumers regarding their sensitive and confidential information. Losing 1% of our customers could translate into millions of dollars of loss. How does Gatekeeper benefit the enterprise? Lowers the risk of data leakage and reduces the risk of losing markets with a lack of customer confidence caused by a security incident. Enables company scalability by reducing the time to integrate with access and new data sources. Providing a superior user experience by reducing the time and the hassle around getting access to data. reduce the cost of applying policies by making policies in digital assets and establishing a centralized policy management, and increase data access efficiency using identity management, eliminating the need for many data access requests. Gatekeeper includes processes for faster, smoother access to data while maintaining security, preventing data leakage, and implementing data governance policies. Gatekeeper reduces data breaches to minimize expenses and increase revenue. Historically, companies that have suffered severe data breaches suffered significant losses, lost customers and their confidence, and it took 3 to 4 years to regain customer confidence, which is a long time to be in that situation. The next step we need from you are to funding Horizon 1 costing $8.5 million for the next 2 years. Join us in making Viasat security, compliance, and data access is a priority. Thank you all. Any questions, please?
Thank you, Team Viasat. Right on time. Questions? Please raise your hand or comment in chat. Great job, team. Looking forward to those questions.
I have a question for the Viasat team, if it's okay to ask.
Thanks. You've got the floor, Mark.
Oh, this is Aaron.
Or Aaron? Looks like we got, okay, so we got Aaron and then Mark.
Is this assuming all data is pulled into kind of a centralized data warehouse? Or can it be extended kind of to wherever data is held in multiple locations, kind of as a overlay singular policy that, or policy grouping that can be applied across many different databases?
Yeah,
that's
so
what yeah.
Go for it.
Go ahead, Jason. Go ahead.
I was gonna, so to answer that question, we'll be relying on the data governance initiative here, which is a bit of a mix where they've got a data layer with some data warehouses and then connect to other data sources. So it is a little bit of a mix. You can do a little bit of both with a connecting layer up top.
And can it be applied to, because obviously, you know, the data in the data warehouse, making sure the right people have access to it, but there's also all of the applications. Can it be extended where a policy is reviewing the access given to those applications as well, and not necessarily just the databases?
Yes, I believe it should. Because the identity and access management systems is using standard systems like corporate AD, Okta, which means it is allowing us to control access across the board for all the different systems that use that as an access mechanism.
Thank you. And nice job, Viasat team.
Thank you, Aaron. Mark, you now have the floor.
Thank you. Great job, team. Appreciate it. Question on one of your slides, Ravi. I believe as part of the second horizon, there was a quote in there about understanding Viasat's culture. I'm kind of curious, you know, understanding how the culture reacts to the first horizon. Has the team talked about how you would actually do that, like how you would measure that and quantify that?
The comment to that one, because that's the funding of Horizon 1 will kind of give us a life cycle of what to implement, what the team is expecting. And definitely, Mark, this is a system where we had to bring everyone together into one platform. And that's not an easy task to support for the whole company. Okay, so by no means we can minimize the effort here. It is a pretty strong effort. At the same time, as the data going throughout the world, every company is in the same situation right now, having this kind of a platform for them to have access and security built behind it, so that it's controlled and we have data in the right people.
The only other one I would say is I don't think we actually have a MOP for that, so it's likely we should actually add one for that to actually measure our adoption itself.
Perfect. Thank you.
Thanks for that question, Mark. Professor Kruger, I believe you're next.
Yes, thank you, and good job to the team. You speak of digitized policies. do you have an example that you could show us how you want to digitize the policies?
So our best example is likely based on GDPR around location-based access, in the sense that only people from certain locations can access certain types of data. So you can control based on the employee's location what they can do.
Okay, that's a good example. And are you planning to do the hard work to actually create the domain model that underlies such policies? Because what you have to do with policies is you have to supply the data into an evaluation function of some sort. And that data needs to be modeled first. Is that part of your plan?
I don't know that we went into a ton of detail on that, so it's likely we need to add that to the plan.
Okay, great. And if I may add another short question, on your list of systems that you had on one of the slides, there was MuleSoft. And I would implore you and the rest of the team to live up to the promise that you made that none of this is settled. There are alternatives to this. And if Viasat wants modern systems, I would recommend to look into these alternatives.
Thank you.
Thank you, Ingolf. Professor Zach.
Thank you. Very interesting presentation. Thank you very much. I have a question about the efforts along the horizons. There are a couple of different ways that people look at horizons. Some look at horizons as a sequential opportunity and just think of their long plan as broken down into sections. Another way of looking at it as an opportunity to have the discipline in Horizon 1 to carry out tasks necessary for Horizon 1 work, as well as success in Horizon 2 and Horizon 3. What kind of things could you be doing now while you're going through Horizon 1 activities that would make your Horizon 2 and Horizon 3 more likely to be successful? Just
so I think
as an example, if I may, the understanding how Viasat's culture reacts, you can start in Horizon 1, prepping the culture. So I'm looking for those kind of things.
Yeah. So part of the things that happen in Horizon 2 and 3 is understanding where everyone is storing their data, and collecting a basically a company-wide survey of technologies and platforms and types of data, and that sort of kicks off the initial user engagement of the platform, and helps bridge the gaps that will come in 2 and 3 of, hey, we talked to you a while back, now we're ready to bring you in, and so they know about us, and they'll be more prepared when those horizons come.
I also think on top of that, we can use that same type of thing that Andrew mentioned to get that whole usability of access, because we're talking about centralizing our access management. There's likely lots of use cases that we haven't even heard of yet for how current access management works. So trying to gather all of those, because that will be the stumbling blocks that we can encounter in that Horizon 2 and 3.
Thank you.
Phil, do you want to ask your question now?
Sure, yeah. Phil Ma from Viasat. Great job, teams. I think it's a very good presentations. One question I have is that as we try to actually overcome the culture and the startup cost to do this, have you guys actually looking into also when we actually get to where we want to be in maybe a couple of years, the synergy basically and the reduction of costs on other tools that we'll be using, so that you can actually reduce basically, I mean, you can actually reduce your spend basically, not because you need to actually change your plan, but that there are things that you don't need to do anymore. And if you haven't, basically, where do you think you guys, what's the first couple of places you think you can look for on those like long-term synergy and saving?
So I guess to start off, one of the easy spots to look for is at Viasat, as many of us know, there are 2 or 3 tools or 4 tools to do the same thing. Likely many licensing costs get cheaper as you use a single tool more. So there's likely spots where certain tools could get removed. And that'd be probably one of the easiest spots to start looking into, if we can get it all centralized for a few tools.
How about from the operational and people point of view? Basically, is it anywhere do we think that we can actually try to synergize that as well?
At the access automation point, where when people are being signed up and set up with accounts to gain access into the network or VPN, a lot of that's done manually. As we start to automate access to data, now you could reduce headcounts and start to get efficiencies and that type of operational cost. So that's one example.
Yeah, I think the other way to expand on that, I don't know that we covered it in a ton of detail, but if you define roles as team responsibilities and have a single thing that contains all of the different systems that team has access to, means that you can just add a person to a team or remove the person from the team, and all of the access requests that you have to do, which often is 5 to 10 when you get added onto a new team, would instead be add them to one team and the rest of the access is granted.
And then the last one, selfishly, being the platform owner for PCI, I do a lot of repetitive manual steps, and our team's working to automate those efforts. Now, if all the teams that have to do these types of audit, documentation, tracking, logging, if all of the teams at Viasat are doing similar things for compliance across all of the company, had similar automation, that could also be a big win for our company.
Okay. All right. Thank you.
Thank you, Phil. Rick, do you have a question?
Yeah, so good job, group. That the need for these sorts of systems in an enterprise is clear, you're articulate. A quick comment and then a couple of questions on your why Gatekeeper slide. You talked about scalability and a better user experience. I didn't hear that really explained or articulated. Your other elements were really clear. It's important when you present this to executives that it's that you are focusing on the key areas. And I think leakage, policies, and efficiency are your sort of winning arguments here. I'm curious about, not that you'd want to share it here, but I'm curious that whether you have a log or record of previous breaches with root cause so that you can prioritize where you might deploy Gatekeeper first. You're right to talk about your cultural problems, and often going to the place where you had earlier problems, they're often more willing, right, to avoid the ramifications of further issues. All right, so my two questions. First is, what about mobile data, either data deployed to a mobile scenario or data generated in a mobile environment? Does Gatekeeper reach to that environment? And my second question, actually our last question, the last speaker made a very similar comment about automation. Is this part of a service-oriented architecture where you can plug Gatekeeper into other departmental automations to lower the costs and to gain this benefit in systems when you don't have to do the implementation?
So right, yes, that's okay. Coming to that one, definitely we have some data to back up the future, like the past securities. So definitely, I can discuss in detail here. Everything from that perspective, from the Gatekeeper perspective, we looked into every time details, see what's happening, how can you centralize the data, how can you make sure data is being accessed to the user in a very short amount of time. And at the same time, the Gatekeeper is not just one component of software to be connected. It is multiple components, and it has to all come together, and definitely it's not an easy task to integrate and roll out to connect all data sources. The good part it is, and we are not storing any centralized data, it's just a metadata coming onto the Gatekeeper platform. Everything is integration to tie this at the point in time. It will connect the data source, current data source, and get the data, send out an email. Even that, every movement is tracked and recorded and sends information to that, as described by Jess and in the diagrams. It goes to the centralized reporting tool where it has access to all the security and ops team and the different levels of security. They can go back and act on it right away. It's like external abuse or internal abuse or whoever it can be.
Yeah. And to expand on that, on the service-oriented architecture, each one of these boxes is its own service and likely will be used for more things than just our system, in that each component of these is being developed and often being RFP'd already. So there is many use cases beyond just what this system is for a lot of these components. So they are intended as service, and one of the services one of their capabilities will be to work within this system.
So you already have an enterprise service bus that you're going to plug these into? Or you're going to deploy them as standalone services?
I think we do. Anyone else want to chime in?
So as you look into that, if you do have an enterprise service bus, the advantage for you is you can plug this in as a service. And to the previous question, the previous speaker suggested, they're going to have their own automations in their own groups. If this is part of a service bus, they can access your capabilities more easily, more directly. They can help with the work of deployment. These are all things to help reduce costs and increase or reduce deployment time, increase usability. So anyway, food for thought as you're thinking. So I would talk further with your architecture team and see how to deploy something like this to get it into the hands of more people who might want to proactively take advantage. Now, this is smart thinking. Any feedback on the mobile question? What about mobile data going to a mobile device or coming from a mobile device? Is that covered in this under these policies, under this process?
I don't know that we thought a lot about doing mobile data. It's likely it might be there if we're using our Active Directory accounts and our central authentication method, which we often are, but we haven't done a lot of research into it yet.
Okay, something to explore. Thanks.
Yeah, I think just to add to that, we definitely did not think about that mobile data, but definitely the way we have cloud service application, we can definitely control who's accessing data where, and without the access, they cannot access data from any UI.
Thanks for the questions, Rick. And I think, Nick, you had your hand up. I don't know if you still have a question to ask. If so, you get the last question.
I do have a question. I just didn't know if we had time for it. So if you'll allow me, I'll ask my question. So you mentioned deviations and the existence in the Viasat culture of those deviations. One of my questions relating to that is, what would you measure to quantify or qualify the cost of convergence? And then when would you disqualify convergence and consciously choose to allow a deviation or create a concession toward non-enlistment of those that you might be wanting to unify into a common data governance ecosystem?
Yeah, so to quantify the cost of deviation, you're really looking at how many people mostly it's going to take to maintain that separate deviance, and will the skill sets for that other system translate well to other projects, or is it really a one-off where we have to hire specifically for that, and that increases the cost of maintaining that as well. And so you have to balance that against the sort of threat of like my way or the highway approach to folding people in.
Thank you.
I would imagine there's certain economic means that you can use to influence behavior, within an organization, but that's a whole nother discussion. I want to thank the team for a wonderful presentation and all the really great questions. We've got 2 more to go, and we'll be starting at the top of the hour. And again, if the team that's presenting, it could be there, say 10 minutes early, that would be great to make sure the slides are all working. Thanks, everybody.
So thank you. Thank you, Professor Wade. Hello, everybody. Thank you all for being here today. My name is Elaine Regini, and I'm part of the wonderful and amazing Team 5. My fellow team members are David Brooks and Chandra Dowling, and we work for Northrop Grumman. Today, we'll be presenting Project Visium, where the motto is communication, connectedness, and clarity. Next slide, please. So what's the problem? The problem is the current design to production process is inadequate to support our company's ability to deliver hardware and maintain current contractual relationships. Now, looking at the right side of the slide, this has led to several manufacturing issues, frequent hardware process failure escapes. Sometimes this results in a supplier disclosure letter, which basically means telling our customer, hey, we messed up and here's how we messed up. Continuing on, our process inadequacies have also led to missed deadlines and excessive rework. And as we all know, excessive rework basically means more money, more time. As a team, we've come to the conclusion that the root cause of all these issues is that we have a siloed enterprise, as very similar to the Cubic team in their earlier presentation, and an over-segregated design to production process, which translates to not having proper inclusion of our stakeholders at key points in our process. Next slide, please. So we're going to expand on the last slide. As mentioned, inadequacies have caused all of these issues. As far as the several manufacturing issues are concerned, we're only going to mention a couple. One of them being constant drawing updates to fix previous mistakes. Unfortunately, this happens too often, and it's pretty common for that entire update process to last at least a week, from submittal, approval, and finally documentation release. Another issue is discrepant components. We've had numerous line stops due to discrepant components, whether the cause is supplier related, as in supplier sending us the wrong parts, or assembly related, where incorrect parts are being kitted to hardware. So discrepant components has kind of been a thorn in the side of operations way too many times. So moving on, frequent hardware and process failure escapes. These can come in the form of those discrepant components I just talked about being installed into hardware and then shipped off to the customer. So furthermore, we've had instances where we've moved hardware through without being fully tested and inspected. Process failures and escapes like these cause us to write those supplier disclosure letters I mentioned earlier. So next, some of the reasons why we have missed deadlines due to not having enough material to sustain a production line. This creates bottlenecks for us in the production process because hardware can't get past a certain point because we're waiting on material to be shipped to us, and we can't further build at that point. We miss deadlines on the sheer amount of defects. We experience defects at the different levels of production, like CCA level assembly test and full module build assembly and test, but multiply that by the several modules that are manufactured at our site, and all of that equates to too many defects. Next, we have excessive amounts of rework. As mentioned, high defect rate, but the worst of it is the test failures that we experience. Oftentimes, we have to troubleshoot down to component level, which can mean sometimes opening up a fully built module to figure out where the problem lies. And we don't deal with simple hardware, as I'm sure the other teams have in their companies. We're talking multi-CCA builds and just about 1 million components, right? Outside of our site, we have supplier issues that also contribute to the amount of rework we have to do. Again, being shipped discrepant material, experiencing long lead times. We even had a case where a CCA supplier decided to modify a component just because it quote unquote looked like it was modified on the drawing. Yeah, bad news. So it boils down to cost and how much we're spending on each of these issues. Northrop Grumman, can't continue to be a Fortune 500 company if we can continue to operate the way you have been. With our project Visium, we hope to save the company millions. The takeaway here is that we need to act, and we need to act now. Next slide, please. In the words of Professor Zach, something we've heard often in his courses, who cares? Well, all of these people care. These are our stakeholders who either influence the production process or execute the production process. Some of these roles, each of Team 5 members have held. I'm a quality engineer, but I got my foot in the door with Northrop Grumman as a technician. Dave Brooks has been a test engineer, but now he's a functional manager. And Chandra is a systems engineer who interfaces with multiple engineering roles. And for those roles that we haven't experienced, we've reached out to those people directly to understand what's most important to them. That's how we've arrived at the last couple slides, and which brings us to the next slide. So to combat our process inadequacies and issues, our BHAG, our big, hairy, audacious goal, our team has come up with Visium. And with Visium, we want to eliminate all those inadequacies and reduce our rework efforts by 80% every year Visium is operational. So how will we do that? So I'll briefly touch on it here. Chandra will elaborate more later. But for Visium, there's two key takeaways. One, we want to target the need to communicate. We all know that communication is key. The most important part of that is maintaining that communication and collaboration throughout the entire process. Not just, hey, this is what we want, go do it and good luck. It's more of where are we at with this step? Do we need more resources? Do we need more personnel? What can we do to make sure we're going to deliver what we say we're going to deliver? This is kind of a nod to one of the books we've had for a course of Managing for Success, where make sure we support our people and make sure we support the people who need it. So the second takeaway, we want continuous improvement. There's always room for improvement, right? So for us, this means having the ability to create baselines. It's pretty much, let's figure out what works, what doesn't. Let's do better and be better overall. Next slide, please. Right. So as a team, we looked at the overall design to production process and did an exercise in identifying where the pain points are. We believe that these are the most detrimental. The first, having several databases that are not well interconnected, causing scattered data. For example, we have Solumina, a database that tracks hardware through the manufacturing and test process. We have Tableau that generates metrics for all of our operations. There's PDM, that is our product data management system that holds drawings, schematics, BOMs, and manuals. There's Doors, that's a requirements database, and there's an engineering workbench that we use as a resource to look up industry and specifications. There are several more databases that we use on top of these, but the point is most of these databases don't talk to each other, and for the ones that they don't do it well. So if we can pull all the information from all these databases and create a singular cohesive interface, our team would argue that our efficiency would increase exponentially. Next, we have communication gaps between departments. As mentioned earlier, not having the proper stakeholder inclusion at key points in the process. We've learned in our master's program about how interfacing within an enterprise helps facilitate success for the intent of the enterprise. With Visium, we hope to bridge those gaps. Lastly, we constantly apply Band-Aids over true corrective actions. Now, this has been the bane of my existence as a quality engineer for Northrop. Case in point, we love to utilize magnetic radar absorbing material, sometimes referred to as MAGRAM or new material. We use that as a Band-Aid to fix signal noise, but rather than targeting a true fix, like maybe adjusting the design to improve hardware's performance, we'll slap some of this absorber material on it and negate some of the signal noise just enough for it to pass a test. And this is part of the reason why we always have constant issues. We're not really fixing them. This forces us to go into a reactive state, constantly fighting fires so we can meet our production goals. But our hope is to change the culture on how we address these issues. And maybe we can go from a reactive state to a proactive state. Rather than fighting fires all the time, we can address issues before they even happen. But you're asking yourself, how will we address these issues? And for that, I'll pass it over to Chandra.
Thanks, Elaine. So with that problem context put in place, I will be talking to you about what Visium is supposed to be and how it will actually work, what its goals are to accomplish resolving these issues. So as the slide presents the overarching statement for what Visium is meant to be, I'd like to counter it with a slightly more specific statement. Visium is a software-based nonlinear system that acts as a singular interface for the users to gain insight into the current status of product build in order to make informed engineering and business decisions. That sounds like a lot to do. So let's talk about what specific goals the project has. First, Visium will present integrated engineering information to facilitate business decision-making. This information will need to include such metrics as material inventory, material lead time, unit failure rates, and corresponding root cause analysis of those failures. Currently, as Elaine stated, these types of informations reside in siloed systems, and it takes significant manual data collection and analysis to reach a effective decision point. Visium will present this information in an integrated format to reduce the time spent collecting and analyzing data. Second, Visium will create seamless communication connections for interdepartment collaboration. Northrop Grumman has currently optimized for efficiency to a point where feedback and interdepartmental interactions only occur after an issue has already occurred. The way departments are notified is by manual notifications, and which not only occurs at the notification of the issue, but also each step of the solution review process. Visium will create communication paths that optimize interdepartmental communication that are non-linear, but do allow for better responses and full stakeholder engagement. Finally, Visium will improve the validation and verification process. Rather than relying on the very heavy manual data collection as stated before, Visium will automatically detect unacceptable numbers of repeated failures and define failure types and failure categories such as minor, moderate, and catastrophic. Visium will also create clear traceability from specific failures to the original design requirements. So what does that look like in action? So this slide presents a user story. We went with a user story over very specific use cases because there's quite a few we could get into, and we do address those in our final report. So let's start with a user story, starting at the successful contract award of what we will call System X. System X initials requirements are input into Visium's databases, and Visium creates a notification to all key stakeholders for the baseline review. Stakeholders then have the opportunity to input any adjustments or corrections for maintainability and manufacturability. We may have a great requirement, but what's the best way to build it? Once that is put in, Visium will then rebaseline, and a notification will be presented to our individual contributors, which is the term we use for our assemblers and technicians. As those individuals begin to build units, they'll be able to not only just notify the system of build completion, but also if there are issues such as a specific cable is not the right length or is having other issues, it can then feedback compared to Visium with what the requirements are, and Visium will create an automatic notification to the stakeholders to review such concern. This is where the nonlinearity comes from. Sounds a little bit like you could get stuck in a loop. Hopefully, the solution comes quickly enough that you don't have to iterate this loop more than once. Assuming we have a successful build and none of those issues occur, we could go on to notify the test teams of their start. At the completion of testing, there's also a similar process of either the test team reports an issue or inputs successful completion. At that point, during testing, if there are any concerns, either Visium can create automatic discrepancy notifications or automatic completion notifications. At that point, the stakeholders do one final review of the baseline of the system, ensure all documentation is correct, and then submits it for final storage inside of Visium. So how are we actually going to do that? Because that sounds like a big project. So some of the specific capabilities we're going to be focusing on is, apologies, some of the specific capabilities we are going to be focusing on are the exportation of engineering and business reports, creation of interdepartment automatic notifications, and creation of directly connected information databases. As shown in the previous slide, Visium will be able to export formal reports at key points in the design to production process. However, it will also have the ability to display informal data exports from any of the interconnected databases. Visium's capability to complete data analysis and comparison from the interconnected databases, along with the capability to automatically notify stakeholders of any concerns, ensures improvement in the verification and validation procedures. The automatic notifications ensure not only that all departments are aware of issues, but also that notifications are not reliant on individuals that may not be available at the time of the issue. So what does that actually look like under the hood for Visium? Keep in mind, this slide is a very high level of what Visium will look like. There's much greater detail in our report. I'll speak to the timeline of the phases that you will see displayed on the screen on the next slide. However, phases are instantiations of certain capabilities inside of Visium. So phase 0 of Visium will be the user Visium interface and report export capability. In building the core of Visium, not only will the team be developing the microservice framework to establish connections to the databases, but also to also be creating the flexibility for future growth. Phase 0 will also be the time where the team ensures Visium has established all of the necessary architecture, cybersecurity, and governance aspects of the system. This includes possibilities of API to the currently networked servers, as well as some of the user-specific interface of a web-based application. Establishing these fundamentals at this stage, establishing these techniques at this fundamental at this stage because of the need to implement Visium on Northrop Grumman hardware. Key aspect of Visium is that it is a software-only based solution. For phase 1, which is in the green box in the bottom left corner, is where the team will create full proxy call functions to the currently existing databases. This includes some of the systems that Elaine addressed earlier. The team will also create the interconnection between the design, engineering systems, and the configuration management systems. Investigation of the possibility of using either a strangler fig approach or just continuing to grow the microservice structure will be done. This is to ensure that not only are we most efficiently using the capability of Visium, but investigating the possibilities of minimizing proprietary interfaces inside of our system. Phase 2, which is in the yellow box on the bottom right, it will consist of the interconnections between Visium and the other databases listed there. It also will include the final user test and iterations on Visium's user interface. So these phases were, as I summarized, were put in place in order to ensure that agile development was successful. So each phase, although with its major goals, has its sub-goals or sub-phases. These sub-phases will allow for the development of key sprints, as well as not only for the development of the technology itself, but also for the documentation. So at the end of phase 2 is the completion of Visium as scoped for this project. I'll now hand it over to Dave to discuss financials.
All right, so let's talk a little bit about Visiums and the financials that we have projected for. Go to the next slide, please. All right, so the 3 phases of Visium boil down to the numbers that are shown on the screen, with a final strike price of about just shy of 3 million. It comes out to about 2.9. The phase 0 that Chandra talked about initially is our main bread and butter. It's the foundation that's going to make the additional 2 phases possible, which is why the effort required for it and the dollar amounts associated with it is a little bit higher than phase 1 and phase 2. Something else to note on the slide, there's an annual maintenance / development fee that we have ever running, right? It's for the length of the actual Visium system, as long as it's in use. The thought process is once we actually get this and put it out for use, we're going to need anywhere from 1 to 2 people continuously, maintaining it, making those improvements. As with everything that we design, anytime you drop something out on the floor, could you make it a little bit different? I'd love to see this, or whatever it may be. So those 1.5 heads calculated to an annual cost of about that. Things to note in terms of our projected costs, none of us on the team, like Elaine had said earlier, we're not software engineers, and this is a software based platform. So what we did was we reached out to our Northrop Grumman software development team and came up with some of these estimates with them, explaining to them what it is that we wanted to do and how we wanted to do it, and inputting their feedback. We also are not accounting, so we reached out to cost account management to find out what dollar amount we should or shouldn't be using for the team members on the actual program. They stated, a good solid estimate for engineering is about 150 per hour. So that is how we came up with some of these figures. Lastly, because we are engineers and I have never not needed a buffer in any of my design stuff, we threw in about a 20 to 25% buffer for unforeseen risk, during project execution. Next slide, please. All right. So now that we know the cost, let's talk about the projected value, right? Cost 2.9 million. The time in terms of years is 1. Some of you are probably thinking to yourself, that's not physically possible. On the last slide, we showed that the estimation, the total hours associated with the project and its development and implementation was 19,406 hours. How do we come up with the 1 year, right? So the 1 year timeline estimate is based off of a 10-person team, where 6 of those persons are working 100% of the time, and 4 are working at about a 50% duty cycle. The growth rate, asset beta, risk-free rate, market risk premium, discount rate, all of those figures we actually pulled off the websites that we received throughout our AESE program to come up with an NPV over a 10-year time phase of about $30 million. We also took into account that as much as we want to state that Visium is only going to make Northrop Grumman money, it's not. It's actually going to add to the process execution just slightly. And the reason why is the way that we're doing it now has gaps, has loops, has problems. As Visium grows, as we learn, and it bonds the end of the finish line to the beginning where we all start with new processes, things, better information, so that we're executing in a more efficient fashion to make sure that when we get to the finish line, what we get at the finish line is what we really wanted. It's going to add to projects in general. So we accounted for a 15% increase in any and all design during our NPV calculations. Next slide, please. Perfect. Okay, so continuing on with the value of Visium. We, the 3 of us specifically, work on the Rancho Carmel Northrop Grumman site. Rancho Carmel is exactly where it is. It's an RC. And the biggest program that we have on that site is our JSF program. It's under the comms business unit. We work on the CNI program, which is communications, navigations, and identifications, which is why when Elaine was talking about the different modules, those are the different things that we use to build that communication systems for the F-35. Anywho, all of our projected values and our figures were specific to the Joint Strike Fighter program itself. And we chose that program because it is the largest program right now on our site. Regardless, there are several other programs associated with Northrop Grumman, right? And several other sites. So if you extrapolate the $30 million NPV for just the JSF program, assume that the rest of the programs just on Rancho Carmel are, maybe 3 to 4 times smaller than this program. Just from our site alone, the NPV, given that Visium affects the rest of the programs as we're expecting it to, the Joint Strike Fighter, now goes from about 30 million to 75 million. And that's just specific to our site. When you extrapolate our site to the 550 Northrop Grumman sites throughout the 50 states, or the 25 countries around the world, the millions become billions. So the opportunity for value added to the company as a whole, based on improving communication and removing some of those system silos that we see, just plaguing some of our, our design to production execution, the NPV is, really limitless. Next slide, please. Okay, so all that being said, there's always going to be uncertainty, right? We don't have a crystal ball that can tell me exactly what's going to happen tomorrow. And that uncertainty adds the possibility of impact to our program. The 4 main pieces that we came up with were project complexity, meaning, Visium as a whole, right? There could be things that we don't know about during the execution that we thought that we forecasted for, but maybe we were wrong. operating systems, right? Visium is a software-based platform that's going to have to sit on something else. What if we decide to go from Windows to Linux or Unix, or what if Windows goes from 7 to 8, or whatever it may be, right? All things that could possibly impact and delay implementation of our system. Probably the biggest concern is culture. You can make the absolute best widget in the world, but if you can't get people to utilize it in the fashion that it was intended to, that it doesn't matter. And our site as a whole is very happy with where we are. Northrop Grumman's been around a long time. We have a lot of people who are set in their ways, and Visium is going to shake things up. So that's a big uncertainty that we want to be aware of. And then the last one was system impact. I think that the best example is the pandemic that we're in right now. We forecast things based off of today, but tomorrow we could be out of the pandemic. Maybe there's not a justification for this, or maybe it gets worse. All of these things have impact to our project and its execution. Next slide, please. All right, so what did we do to try and mitigate some of those things, right? What are we doing to create value options that can be used during the execution of Visium as a whole? The agile development process, I think, is going to be key. The go, no go milestones throughout our design and implementation will give us the staged investment option. For culture, I think it was Professor John who said pick minimum 3, no more than 5. You need more than 3 but less than 5, and then continued relentless, just keep saying the exact same thing. You got to get the people on board, and you got to get them to understand why. We also figured we'd do periodic surveys to communicate with the people and find out what our users are liking and what they're not liking. That gives us the option to switch. We could be going down one path and determine that the users and stakeholders maybe want something a little different. So feedback is extremely important. System impact, of course, the phase rollout like we talked about, and then the operating system, like stated prior, design on multiple platforms, give us the opportunity for growth, and or picking an OS and sticking with it, and then moving together as one, as opposed to every time something new comes out, trying to revamp or redesign the wheel. Next slide, please. All right, so what's next? Next, we're going to present to all the Northrop Grumman stakeholders. We need to make sure that we acquire funding for the project. And then when we do, we're going to do a tiered rollout approach. So tier 1 is project phase 0, which is the foundation, right? Once we have that foundation, we can move on to tier 2, which is project phase 1 and 2, which is where Visium is now complete and we have full capability. Tier 3 is where we expand to all of the other smaller systems. That Elaine, I think, talked about it. There are so many, it's difficult to keep track of all of them. But tier 3 would be a site-wide, everyone uses Visium at the Rancho Carmel site. Tier 4 is where we expand that from Rancho Carmel to the rest of the 550 sites throughout the Northrop Grumman Corporation. Next slide, please. All right, so in conclusion, what's our problem? Our biggest problem that Visium is going to fix is our inadequate process. The way that we're doing it now isn't working. Why do we care about it? We care, so what, right? Why do we care? We're losing millions. We're literally leaving millions of dollars every year on the table for no reason other than we just left it there. What's the solution, right? Visium is our proposed solution. How's it going to work? The 3 C's: communication, connectedness, and clarity. And what's the impact of Visium? That's the money saved, right? When you think of Northrop Grumman is one of the top 5 Department of Defense contractors in the world. And if we want to remain the top 5 and or move our way up to the 1 spot, we need to do what we do better. Today it may work, tomorrow maybe, the day after, who knows? I don't want to be the next Kodak or the next Blockbuster. I want Northrop Grumman to maintain number 1, to be honest. I don't want to be at 5. I'd like to be number 1. Improving our efficiencies, removing those silos, bridging the gaps between the islands and the ocean of Northrop Grumman. That's how we get there. And Visium helps us make that happen. Other than that, I think we're pretty much done. So I guess we'll open it up to questions.
Thank you for the presentation. Exactly on time. Well done. Looking forward to the questions. If you've got a question, please raise your hand and step up to the bar. Oscar, please ask the question. You have the floor.
Thank you. Great presentation, guys. A couple of challenges I noted while you guys were going over your presentation. The biggest one is that we ourselves are not vertically integrated at Northrop Grumman, right? So how do you plan to flow this down to your supplier base? Like, are you going to make this a condition of them being a supplier? And if so, how do you deal with cultural resistance to that? Since you're basically forcing down Northrop Grumman processes on independent corporations, or is that not the intent?
So initially, I was just going to say initially, no, that is not the intent. I could speak to it a little bit more, but for the sake of time, I skipped over it. But we're actually going to be using the Open Group Service-Oriented Governance Technical Standard, which is very much an internal system structure. And we are planning this to be internal to Northrop Grumman, specifically for the units that we are creating in-house, because that is our biggest challenge. And that's where we've had the experiences that we've had that Elaine referred to and some of our stakeholders. We focused it onto that because from my background, I was not ready or prepared to be as brave as Cubic in saying we're going to fix how we even do global supply chain integration. So Visium is the first step inside of Northrop to change internally.
I'd also, I mean, just to kind of, follow up on it, right? Not to say that we as a company and even our suppliers aren't open to it. 2 weeks ago, a fellow coworker of mine was in Australia visiting BAE, one of our suppliers, and our suppliers want to help us get to where we need to be because it helps them get to where they want to be. So we're trying to actually bridge the collaboration between Northrop Grumman and its sub-tiered suppliers. I mean, even now, I think that Visium as a whole and the software will make that process and or capabilities a little bit easier, because the information that we flow to them is only as good as what we flow to them, right? If I'm flowing misinformation because we haven't gotten our stuff in order, they're going to execute exactly how I told them to. So fixing our end first makes our sub-suppliers' capability of doing their job to better support my needs even better.
Thank you. And then one last follow-up there. The term defects, right? To me, there's really two kinds of defects: design defects and manufacturing defects. You're seeming to bridge both. Or is your intent to do that, like full life cycle, or do you want to start fully with manufacturing defects first?
I'll take it if you guys want. Okay, cool. So it's kind of both, to be honest, right? Great example: design defects. A lot of times. Or let's start with manufacturing, right? I have a manufacturing defect. I'm continuously failing a noise floor requirement that we have imposed on ourselves through our functional confirmation at the module level, right? That defect, which we're arguing is based off of the manufacturing process and how well we do or don't build the hardware. When we actually went through the manual process, we found out it was kind of a combination of the two. There was no necessarily fault on either side, but what we determined due to a lack in communication was the technical specifications that we defined for functionally confirming the hardware before we shipped it ended up having far too large of a guard band before you got to the actual deliverable hardware requirements. Arguably, the communication and bridge between design and then manufacturing test and the producibility and things like that, we could have seen this and then shortened that, right? The measurement uncertainty of the STI that we were using was actually a lot better than what we had thought it was going to be. So we did a combination of two things to fix that quote unquote defects, right? We changed up the specifications because it was allowed, and the manual digging into the process and all the different systems allowed us to show that. We also, my manufacturing engineering team, they got together and came up with a little bit of a smoother process to actually build the hardware. So on both ends, we were kind of able to meet in the middle to accommodate the squashing or mitigation of the defect.
Thank you for the question, the response. Thomas?
Yeah, thank you. Interesting stuff. Who owns the decision to go from stage 3 to stage 4? That is, from using this at your site to using it at 549 other sites. And have you talked to him or her?
So I've been I've been working with my D2 and actually my VP at the mission system sector at my site. And they're our big stakeholders. They're the ones carrying the torch for early onset collaboration in operations between design and bridging, removing those silos. Luckily, they hold titles that they do, not as opposed to the rest of us. And we are hoping that when we do get to that fourth stage, they will make a phone call and express, hey, we have something going really good for our site. I know that there are cross-site collaborations. In fact, that VP and D2 manage multiple sites. So certainly under their things, it would go. But when we start moving from sector to sector, it's going to come down to their ability to reach out and network. I'm confident in them, though. I think that when this battle that they've been pushing for personally right now becomes more of a realization, I think that the business justification behind it will make the decision fairly simple.
You have a new COO who should be very open to integrating process and design, right?
Yes, it's funny, that COO, I walked through my manufacturing floor 2 days ago, and I was less nervous with him than I am today, just saying.
Cool. Happy to hear it.
There's some misplaced trust, but anyhow.
That's funny.
But you shouldn't be nervous on my behalf, at least. So thank you very much.
Yes.
Nice work.
Thanks for that, Thomas. Nathan, you have the floor.
Thanks, John. So first, I just want to lead in with, as a fellow Northrop employee, I am extremely empathetic to the issues that you all are probably, facing now and ultimately drove you to take on this project. The process between envisioning a design and putting it to a manufacturing floor to a supplier subcontractor has consumed most of my own career at Northrop Grumman. So I'm, number one, very aware of the issues, but number two, very interested in the value of seeing a lot of those roadblocks removed. So a couple of questions. In your mitigation and options slide, you mentioned continued and relentless interactions with the system. And, my own experience with this is that there are already continued and relentless interactions, but they often take the form of a project manager sitting on top of your desk, pushing for design or stakeholder release. So I'm interested to see how Visium would alter that perspective in something that's a little bit more warm and fuzzy to the user. My second question has to do with our own internal digital transformation initiatives, what those interface points are with Visium, where you're touching, the PLM and ERP systems and MRP systems. You mentioned Solumina as one of them that we're standing up across the enterprise, and particularly with major platform programs. And if so, can you kind of share what that landscape looks like?
Well, if you guys don't mind, I can talk to at least the interfaces portion and a bit of the technical to that. So our plan is, since Northrop as a whole is definitely pushing towards cloud storage and network systems and all of that kind of format, we're definitely leveraging a lot of the current API structures that exist, specifically with some of the cybersecurity concerns as well, because of the type of information we'll be sharing. But that was the whole point of strongly focusing on a service-oriented architecture with a microservice structure, and then potentially looking at leveraging Strangler Frig to bring in some of those data analysis capabilities, or I believe it was Cubic and some of the other folks mentioned with SAP, and how much of that do we bring in, or do they do it well enough that we just create that proxy interface? So technically, that's kind of where we're looking and doing and building that interface process with inside of Visium. I'll leave it to Dave and Elaine to talk to some more of the warm fuzzies as far as Visium being able to create connections. I know for at least my experience with some of my program managers, they just want the very clear 5-minute information on current status. And a lot of that takes a lot of manual effort on my part currently. So what we want to be able to do is, without having to have them sit on my desk, specifically walking across my keyboard like my cat does, we would have them be able to interface, pull a report very quickly that is filterable to the type of information they are interested in. So ideally, all of that capability is in one singular interface. Dave or Elaine?
Yeah, just to kind of carry on, with the whole relentless continued interaction with the users, right? The concept of Visium is to do exactly what Chandra just said. As much as I love, my OPMs knocking on my office door every 30 seconds, asking me where I am with that design and why it's not on the floor yet. That's the goal, right? I have a number of, I run a team of about 40 engineers, and my engineers come to me often and tell me things like, hey, I need to present in this meeting, but in order for me to present in my meeting, that means I have to stop doing what I'm doing to go present. So the channels created by Visium to pull that data will hopefully fix some of the cultural problems. I have people on my team who are like, oh man, this OPM's driving me nuts, or this this program manager, whatever it may be. And everyone, it's always easier on the other side of the fence to say how that person's job should or shouldn't be done and what they should be doing, right? So hopefully the system as a whole will give the insight to remove some of that back and forth bantering. And then, making sure that people are utilizing it, the relentless, talking with them. We and the leadership team, we actually talk bi-weekly about how it is that we are engaging with our teams in order to, establish a better culture, right? So that the wants and goals of the Northrop Grumman Corporation as a whole are being flowed to our people. This is arguably a system that could be used by the users to to move us closer to some of the bigger goals. So flowing the constant relentless, hey, have you guys seen how easy this is? You just did that, maybe you could do it this way. I think is probably a good start. Arguably, no person is the same. I have 3 children, and all 3 of them I talk to very differently depending on what it is that I would like them to do. Or if you're my daughter, she doesn't have to do anything. She's perfect. But anywho, that I think is how we would start. And then based off of the feedback and right out of Professor Zach's class, mirror them, understand them, right? Get to know the person so that you can flow information to them in a fashion that best fits what they need and what you need to accomplish. That's my thought.
I have a hand up here. Oscar, would you like to take the floor?
That may have been a hand up still from previously, in case I'm wrong, Oscar.
Okay. Any other questions? Got about another minute and a half. Well, sounds like we're done. Thank you, team, for your presentation. Enjoyed it. Thanks for all the questions and comments. So at the top of the hour, we'll be going through our last presentation. So have a good 15-minute break and see you back.
All right, thanks, Professor. So hello, everyone. Good afternoon. We are the final project for today, the Digital Engineering Factory, and we're here to talk about what we consider to be the factory of the future. My name is Shailesh Sujanani, and my co-presenters are Brittany Chairez, Eric Gonzalez, Hector Laren, and Jonathan Dang. So without further ado, let's continue forward. So imagine a world where for every combat system you develop, your adversaries develop a counter and elevate their defense. How do we keep up and ensure that we maintain our advantage? Now stop imagining. This is the reality of today. The question we must ask ourselves today is, are we prepared to deliver the combat systems of tomorrow? Our customer must evolve, and we must evolve with them. We must lead a rapid change in the current defense industry. But there are inherent blockers within our company to this strategic modernization. Today, we will talk about these issues facing our company and our solution to overcome them. With that, I'll pass it on to Brittany, who'll begin talking about some of the issues we're facing.
So our main problem is fragmented tools and processes that's currently limiting our ability to respond, and it's generating inefficiencies. Our current tools don't allow for a lot of collaboration. There's gaps and errors, and sometimes they're not even identified until nearly the end of a project. Unfortunately, we have programs that still operate in silos, and they're using outdated processes and may not even be aware of a sister program that has more advanced ones available. These examples are slowing us down, costing us billions of dollars and hindering our potential. We are hiring new talent that has been educated and trained with more modern options than we are required to use. This is additionally impacting our ability to retain individuals. We challenge our company's employees every day to innovate. And in response to this challenge, we have developed a solution within the Digital Engineering Factory. Our proposed Digital Engineering Factory is going to bridge the gap by providing standardization between these tools and processes. Our toolbox will include options to support all phases of the lifecycle, from planning, design, development, and testing, and creating an improved, streamlined workflow from inception to our end product. Users will have the ability to select and follow one of the tools or processes from our framework that fits their needs and apply it immediately without having to recreate or search around, losing critical labor hours. They can also be confident that all of the items in our toolbox are credible, updated, and aligned with our customers' expectations. This is already being done in a very compartmentalized fashion, and the DEF is the resolution to make it accessible to our enterprise supporting a team of teams. Ultimately, implementing the Digital Engineering Factory will further prepare us for the future in business. It will assist us in retaining our top talent and align us with today's modern world. Our concerns not only lie within the operations of our company, but this is rather merged into our customer as well. So why the Digital Engineering Factory? Because we're not only trying to improve these attributes internal at Northrop, but these changes are now more than ever imperative to continue to stay relative and profitable. We are currently seeing multiple contracts come out of the Department of Defense that are starting to require this type of digital engineering factory or some sort of digital strategy that needs to be included in the process. We need to be ready and able to respond to this in order to be considered a contender in the arena of these future contracts. Speaking of future contracts, I'm going to send it over to Jonathan, who will now share what our competitors are currently doing.
So as Brittany was mentioning, there are hundreds of billions of dollars in contracts up for grabs in the near future. The industry is aware of this. Our competitors that are newly emerging are aware of this. We have new challengers such as SpaceX and Blue Origins that are becoming big name players in the space industry and are taking up our contracts. There are also well-established digital enterprise in Google, Amazon, the Microsofts that are looking at penetrating further into the defense industry as well. The customer sees this and are looking outside the legacy defense contractors in Northrop Grumman, Lockheed Martin, Boeing, and Raytheon. We are slowly becoming obsolete if we don't adapt. Northrop Grumman is at risk of losing out on billions of dollars in contract awards. SpaceX currently have approximately $7 billion worth in government contracts and growing. Blue Origin is currently at $500 million, but they are also aggressively pursuing additional contracts, potentially worth upwards of $10.2 billion. Google, Microsoft, Amazon are combined over $50 billion in contracts and are currently providing the customer with their digital infrastructure and methodologies. This gives them a huge advantage over us as they are producing the products that we are looking at implementing. They're the current pioneers of digital engineering for the customer and well-versed in digital engineering. Not only are our emerging competitors taking away our contracts, they are also delivering at roughly half the time it takes us to field a product. They're already taking our talents, which it's a major challenge in us losing more talented employees than we are hiring. And it's only a matter of time before they start penetrating the products market and start taking our potential contracts as well. Digital engineering is the inevitable future. Our current competitors in Lockheed, Boeing, and Raytheon, they recognize this and are looking at modernizing into a digital engineering strategy. Our potential competitors in Google, Amazon, and Microsoft are well established in digital solutions and are in prime position to take over the defense industry. For us to survive and to continue our dominance and maintain success, we must adapt, expand, and lead. And for that, Shai will talk further into the digital engineering factory and how that can help resolve our issues.
So in addition to our customers looking outside at different corporations, they're also themselves adapting and modernizing. In recent years, the Department of Defense has released multiple digital engineering strategies and reference architectures. They are moving at a rapid pace to incorporate digital engineering and, as stated prior, are requiring new contracts to include digital engineering as a core capability. With our customer changing the way they do business, our company must adapt and change our ways, or we risk getting left behind. Our customers are already implementing their approaches to digital engineering, and they have been for many years now. For example, on the bottom of the screen here, we've got 4 different digital engineering implementations from our customer. The first one, which is M2O, is a digital engineering environment for our intelligence agencies, or at least a portion of it. Next, we have Platform 1, which is the US Air Force's digital engineering environment and DevOps environment. Our customer has even gone a step further and developed a core shared repository of secure hardened software for major efforts. Programs, companies, and efforts within the Department of Defense can all leverage the tools that come out of the Iron Bank, which is essentially this core repository. Lastly, they took it even a step further and created a consolidated cloud infrastructure to connect all of their digital engineering environments. These environments serve as an example and a message to the companies who want to do business with them. The digital engineering factory is our comprehensive answer to their call. If we don't adapt and modernize with them, we will get left behind. And with that, I will pass it on to Hector. We'll take you through our plan on how we expect to deploy this digital engineering factory.
I am going to go over the timeline of the development and deployment of the digital engineering factory system. The proposed timeline should take approximately 3 years. And the first phase has to do with creating an initial design and perform rapid prototyping. We plan to provide an early demo and perform stakeholder feedback and adjust during this phase. Agile process is planned to be used during the development of our system. During the development phase, we plan to implement portions of the core capabilities, which are the standard environment, central repository, centralized infrastructure, cybersecurity, and contingencies. In phase 2, we plan to complete the initial operational capability milestone and continue to developing the core capabilities. We also plan to start integrating the use of our system with a first pilot program. We would make adjustments to the configuration as needed for the pilot program, also address any issues that emerge during the development of the system. At phase 3, our system would meet the full operational capability milestone, and the pilot program will reach its first IOC milestone. We plan to start the integration on a second program to use our system, also add additional capabilities based on stakeholder needs and changes in industry. On the next slide, we will go over the digital engineering factory system architecture. So the figure shown on the right-hand side is the core overall services for the digital engineering factory system. The system consists of 7 services, which the first service is a lab interface. which connects to external labs to conduct testing on test beds or production platforms. Second service we have is a toolbox service, which is a repository of approved vetted tools that are recommended to be used. Third service, the user interface service, is the primary user interaction with our system. The factory service is the data bus that connects services of the digital engineering factory and facilitates the system modularity. The fifth system, the fourth system is a monitor service, which provides continuous system monitoring and reports suspicious anomalies. Metrics service aggregates all system statuses and provides standard metrics. Finally, the last service is the model repository service, which contains all the descriptive and analytical models needed for production development. The next slide, Eric is going to go over the service oriented architecture.
So in our enterprise approach, we'll be utilizing a service-oriented architecture. This type of architecture will facilitate standardization, and it provides governance for the digital engineering factory. We'll be utilizing a core engineering cloud environment, and we will be leveraging our core infrastructure that is already in place. And that infrastructure is not only in our existing network, but it also encompasses all the vast knowledge of life cycle guidelines and existing proven processes that we've gone through. We have all this repository of data that we could use. We'll be able to use those guidelines and create a template and deploy it to various programs and divisions. And then each program will then be able to incorporate it and tailor the parts of the template that they will need for their specific project. Now, with such big changes, one of our biggest challenges will be the culture. To overcome it, we will need to obtain a committed buy-in. And we have a strategic communication plan with our stakeholders. We'll be utilizing a top-down approach and working with enterprise leadership. And with this approach, it will help us align to our company's vision and our goals. Now, Northrop has the capacity and the capability to modernize as we move forward. So changing the culture and how we embrace change as a whole will be our biggest challenge and also our biggest opportunity. Our challenges are derived from our stakeholder meetings. We met with multiple key stakeholders from our leadership teams, and we found a significant amount of similar themes with stakeholder goals and concerns. We had the opportunity to speak with our chief software engineer, and his major concern was, how do we reduce software defects? He was extremely concerned with the impact these defects have on projects and how they could be improved. We spoke to our chief systems architect and numerous other employees who would like increased collaboration. They worry about the silos that are created from our work culture and from the type of sensitive projects that we work on. And then that leads to like an example for like some of us may be working on project A, but we have a sister project B that may be doing the same type of work, but each are individually starting from scratch and not gaining from each other's learned processes or anything. And this type of scenario has been carried out this way for a very long time within our company. And then we also spoke to engineers, and most engineers are asking, how do we improve our engineering lifecycle as we are facing more competition with other companies that are already adapting faster than we are? And then also most employees, well, actually, as a company, we're also concerned with employee retention, especially now so when we are losing more employees than we are gaining. And next is Jonathan.
All right, so As Eric was driving a couple of points home, culture being a big issue, major issue with implementing anything new, really. I mean, it's in people's general habits to not want to change if things are working, but again, the willingness to adopt new technology is going to be key to making this a success. But the digital engineering factory is a culture and workforce enabler. It's going to help transform a culture and workforce that adopts and supports the digital engineering across the life cycle. It brings about a strategy that promotes communication, engagement, leadership, strategy and implementation, training and education, and continuous improvements. To address some of our key stakeholders' concerns, the digital engineering factory will improve the engineering lifecycle effectiveness through standardization. As Eric mentioned, there's silos, there's no standardization. There's a lot of issues with down the line with integration, collaborative efforts, but a modern set of standardized tools and processes will reduce costs through reuse and help minimize downtime, improve disaster recovery. A centralized platform and repository will increase collaboration between silo teams as well as aiding in integration efforts. With more advanced tools and collaborative transparency available, along with continuous development and continuous improvements, defects are identified sooner and resolved more efficiently. So things will be caught more quickly, and it wouldn't be till when we're at the end of the product line catching, because that's going to cost a lot of costs in resolving that. But catching these defects quickly will lead to more quality end products. A modernized tools and process will provide employees with an improved experience and reduce training required. This will help them keep them engaged in more interesting work and not focusing on training new tools when they move from program to program. So this allows them to focus on their product at hand and let them provide their full attention to the critical systems at hand and pretty much create a better product. I mean, as they say, a happy employee is a productive employee. The digital engineering factory also logs data continuously and provides a knowledge repository for all to easily access. Knowledge will not disappear when our experienced contributors retire or leave. All available product data will be archived for continuous reuse and improvements. Models are generated based on data trends, assisting developers to make the driving decisions for the product lifecycle. Overall, this reduce cost, modernize tools and processes, quality products, and a satisfied workforce, and increased opportunities will allow Northrop Grumman to remain competitive. So improved collaboration, streamlined processes, and modernized approaches enables our regular performers to progress into high performers with the help of valuable resources being readily available and a historical data repository at their disposal. This also allows for our junior engineers to quickly integrate themselves and be productive members of the team. And again, as Eric was saying, attrition is a huge issue. So with our experienced and high-performing contributors either retiring or leaving for our competitors, where does that leave us? So we must take action to maintain an effective workforce and remain relevant. And this all sounds easy and all, but you might be wondering, how much does this all cost? What's the financial issues of this? And Shai will walk you through that on the next slide.
All right, thanks, JD. So yeah, as JD mentioned, the real question here is, how much is this going to cost me? So a couple of things that's worth noting. On a previous slide, we talked about the hundreds of billions of dollars worth of new contracts coming down the line. In addition to that, Northrop Grumman actually has a backlog of about $76 billion worth of work Includes everything from new development contracts to manufacturing contracts. There's a significant amount of money that we stand to gain essentially in the near future here. However, one thing to consider is that for every single one of these projects that is required to have a digital engineering factory, we would be creating this exact system over and over and over again. So for our financial analysis, we essentially took into account how much would it cost us to develop the digital engineering factory versus how much would it cost us if we didn't. We actually have an up on in our project, and that is that we have already in the company had efforts to develop a system and do a lot of the NRE required for the digital engineering factory over the last couple of years. And our team has been involved with that in many different ways. With that, we've come up using the basis of estimates of those past events of a $5 million IRAD cost over a span of 2 years, our phase 1 and phase 2, to develop the digital engineering factory. From that point onwards, the cost to implement that onto programs would be roughly about $2 million of CapEx. This system would include a consolidated and standardized mode of all the best practices from various divisions. Our efforts in the past have shown us that every division has attempted to do various pieces of this, and even some of the projects that we've heard today have actually also been encompassed in certain portions that could be included in the digital engineering factory or be linked by such a factory. If we didn't do this, we know the cost of actually implementing a brand new solution would be roughly $10 million of CapEx for every new contract that comes on. This would be a siloed, independent, specific capability for every contract. And that cost is exponential. If we've got $76 billion worth of contracts coming in, you can imagine what that would mean. Our analysis was very simple. We took one contract per year and we evaluated it as if we were to have the digital engineering factory or if we weren't. And we assumed that with that $10 million CapEx, it would exponentially grow as you continue to move forward. And we would be able to save money significantly if we had a standardized digital engineering factory. Those are just the bottom line numbers. The additional benefits that we would gain would be savings from volume licensing, the retention bonus that we would get in for our employees in terms of utilizing standardized tools when they're moving between programs. These types of costs are things that, while we did take into account, we chose to keep them as a side component and focus more on just what is the raw cost of implementing the system versus not. And if we look at a 10-year evaluation, we see that we have a $80 million savings in just our raw numbers going out to the 10 years. With that, I'm going to go ahead and pass it over to back to Jonathan, who's going to give us just a final overview on our benefits and close us out.
Sorry. So modernize, centralize, and standardize. The digital engineering factory provides a modernized vehicle for product lifecycle development, a centralized infrastructure for collaboration, and standardization to drive efficiencies. Throughout Northrop Grumman, there are multiple silos, multiple teams working in fragmented environments, utilizing distinct tools, processes that risk causing integration and collaboration issues down the line. This is driving inefficiency and limiting the ability to respond effectively. Modernization, centralization, and standardization will resolve Northrop Grumman's bottleneck in collaboration, inefficiency, and not being prepared for the future. The digital engineering factory will meet our customer mandates, reduce costs, drive efficiencies, and increase innovation across the enterprise. Increase product throughput, reduce downtime and overhead costs, and increase product quality are ultimately the resulting benefits of the digital engineering factory. And of course, this also means an increase in revenue for Northrop Grumman. So we asked the enterprise again, are you prepared to deliver the combat systems of tomorrow? Enter a new era of engineering, digital engineering. And I'll turn it over to John for questions.
Thank you, team, for your presentation. This is a chance for people to raise their hands and ask the team some questions. Andrew, you're first up. You've got the floor.
Oh, thank you. Thank you, Professor Wade. First of all, it's very impressive what you guys working, especially talking about the unifying the tools and then breaking down the silo. It's definitely a challenge that what every enterprise been doing so far. Now, the questions on your enterprise architecture, right? So you talk about the unifying the solution, the tool, right? How is your struggle with the data unification? Some of the data in particular enterprise could be, you know, just a regular CSV or some sort of like a plain files, right? What is your strategy on unifying this information?
Yeah, so we actually have an advantage here in that the company has undertaken a massive digital engineering or digital transition. And with that, they've actually begun to take a lot of our core processes and implement them. One of the members of our team is actually a manager for one of the teams that's doing our process implementation. With that, it governs a lot of the data that we produce in terms of the documents that we produce, as well as also data from actual systems. Within our architecture, we intend to provide essentially a common repository where these individual programs or individual teams can then move their current CSV files or XMLs or whatever type of data structures they have into this common repository and then leverage it as they move forward. We don't want to instruct a program on how they need to operate. If they need to produce a CSV file to as an artifact for the customer, then we're by no means do we want to stop them or inhibit them in any way, but we want to provide them a common place to not only store that data that's backed up and well maintained, but we also want to provide them essentially a structure that allows them to pull that data when they need it and even automate uploading and pulling that data as needed. And so that's really where our system comes in key. And then when we bring in our process side to it and we talk about the higher level processes of the company and how we're digitalizing a lot of that, that will start to govern what the actual outcomes of these documents can be. And in future contracts, we can state what the types of documents and what the types of artifacts we're going to be delivering are, utilizing our own CCOM. And if the customer agrees to it, we can provide that framework for how those teams should be delivering it. But really the hardest part about this is that balance between what our legacy programs are doing and what our future programs are doing. And so from that perspective, the data management portion becomes difficult. And so we don't want to inhibit programs. We just want to provide them with some structure and a good place to manage and put all that information in.
All right, great answer. Thank you.
Thank you, Andrew and team. Laura, you've got the floor.
Great, thank you so much. So this is Laura Otero. I'm one of the digital transformation leads within Northrop Grumman. We actually have a very similar solution than you guys are proposing. And I noticed that a lot of your stakeholders are very engineering focused. How are you guys accounting for the manufacturing operations and global supply chain portion of the factories of the future?
Sure. So in our architecture, we decided that we were going to keep it as modular as possible. Our first approach is going to be the core engineering, the development, the planning, the design. And then from there, we would actually move out. But we did leave essentially an opening and a connection into our system for further expanding that into the manufacturing, into the business phases of the actual system. And with that, you can see we have a lab interface, and that lab interface brings us not only to our test labs and our test infrastructure, but also into our manufacturing labs and manufacturing infrastructure. The idea being that we can push a design directly to essentially a manufacturing system and let it either automatically build the system like what we're doing for F-35 with a lot of the digital integration there, but then also receive feedback and allow us to make changes on the design phase if necessary.
Great, thank you so much.
Oscar, looks like you're next in line on my screen. You've got the floor.
I just want to follow. Thank you. I just want to follow up with what Laura brought up. I think beyond those groups, we also need to bring in, legal compliance, and even the data owners themselves. Right, you're gonna face challenges where some information is classified or otherwise distribution F, and you can't share it. And appeasing those stakeholders and getting them on board will require you to figure out a way to safeguard their data in such a way that sharing is still possible, but you protect the information that you really want to safeguard. And I think they're going to be key stakeholders. They could stop you. Those are the people that have that power.
Correct. And one of the considerations that we essentially decided on is that while our architecture is being developed in an unclassified fashion and enterprise-wide, we can have an enterprise system like this when it comes to dealing with data that is, CUI or proprietary in that way, or even classified data is probably the best example. We can actually take this architecture and implement it either on a classified network or in a way where we have that CUI data protected. And that's really where a big advantage comes into the system, right? Is that we can replicate it based on our templated design. And if a program doesn't need every aspect of it, they can only pull the parts that they actually need that meet their contractual obligations.
Thank you for that. Thomas?
I just wanted to add to that.
Yeah.
Sorry. From our stakeholders chart, we also added the business team. We wanted the business team input, but we have not had a chance to get with business leadership yet. So that is definitely something we want to implement and add to our project further down the line as well. So as Shai said, this is modular and we can add to it as needed.
Thank you, Jonathan. Sorry for the interruption. Thomas?
Yeah, thank you. Very interesting. I'm always intrigued when I hear factory of the future or words like that. At the same time, I must also say I oftentimes don't quite understand what it is. So maybe I misunderstood what you were doing, but what you're doing seems to remind me of what other companies have been doing. And maybe you can tell me what's the difference is between this and maybe Autodesk or Siemens MindSphere or Microsoft Azure. What is it that you can add that they already haven't thought about and have been developing this for many years? So maybe I'm misunderstanding, but it reminds me of some of the things they are doing. So if you could perhaps tell me a little bit more about that.
Sure. So we'll take the Microsoft Azure or even AWS as another great example as essentially our baseline. Those cloud infrastructures or those environments provide a whole bunch of tools to essentially produce this entire engineering lifecycle. The problem that we have is that a lot of those environments are very specific and we actually can't use them in a way that's necessary for our programs, projects, and our contracts. The reason being is that with the various customers that we deal with, and actually the slide where we had the various our customer integrated systems, they're on different platforms. And so while one may be using Azure, another one may be using AWS and so on and so forth, our system rises above that and takes it one level higher. It's an entire architecture that we can put on top of a Microsoft Azure or an AWS or any of those types of cloud infrastructures to do the jobs that we have to do for our engineering purposes. In addition to that, those key capabilities may not be allowed we may not be allowed to use the core Azure capabilities or core AWS capabilities for security reasons within our own company. And so with that, we have to come up with our own architecture that will be approved essentially at an enterprise level on both the security side and also our compliance side to meet the various customers that we have. And that's where we really differ from those infrastructures or those items that have been, or those systems that have been produced by commercial companies, is that we're really developing a cloud system for ourselves to develop the products that we develop that has the compliance and security already built in.
Thank you.
Are you next, Art? I believe you are, at least on my screen. You've got the floor.
Oh, hi. Did you say Art?
Yes,
yeah.
I did.
Oh, okay. Okay. Hi, Art Villanueva here. I'm a graduate of this MA MAS for AESE 2012. So I used to work at Northrop Grumman. What used to be Information Systems. I work at Dell now. I'm the chief AI machine learning architect at Dell Federal. So one of the things that we focus on is digital engineering. One of the things that I didn't quite get when, in this whole presentation was, what is your definition of digital engineering? There's a lot of definitions of digital engineering. What in your, as you do this, what does it encompass? Because digital engineering in a lot of cases includes digital twins, right? Digital includes MBSE artifacts. It includes all kinds of other stuff, digital threads. What is your definition?
That's actually a great question. And we actually had a little bit of a struggle with that initially because digital engineering is such an analogous term and can mean so many different things. With that, for our purposes and what we're trying to develop, we're sticking specifically to an engineering lifecycle factory, very similar to a software factory, but expanding it to include other elements such as the planning, the design, and also the testing components of it, and not just the software centric approach that most DevSecOps teams or most digital engineering factories or software factories approach. And that's really what our term digital engineering is referring to, is it is a holistic approach to how should we deliver a product from design inception to our testing and then out to our customer.
Okay, great. So it does not include necessarily the digital twins.
No, and we did leave room for that essentially because we do have our model repository that we built in as a core service. However, the intent is not necessarily to build up a complete digital twin within our architecture, but if a program does have the need or is going down that route, they would have the models to essentially leverage.
Gotcha. Yeah, thank you. If you're interested in looking at sharing like 3D models, take a look at NVIDIA Omniverse. They have a pretty good software there. Okay, thank you.
Thank you.
Rick, you're next up online.
Yeah, just some feedback. So congrats on the vision. It's big, it's modern. Someone else used the term BHAG, a big, hairy, audacious goal. All of that's great. One comment you made when you were being asked about how do you differ from some of the cloud providers, you talked about services you might offer that they don't, or how you may not be allowed for security purposes to use those. You should check in. All of the major providers offer on-premise cloud, and so you can get you can leverage tools like Azure or Google Cloud or AWS that have all that infrastructure with complete security and control inside your organization. I suggest that you look into that. One is it'll give you some insight and maybe ways to be more competitive, but two, it might save you a great deal of time and money. And I'm sure someone else will ask you about it if you talk about this in front of an executive committee. I expect this would come up. So you might want to check into that and see how relevant that might be to helping you build out what you want to do cheaper and faster.
No, totally. I'm right there with you. We actually within our programs have all not only met with, but have to use individualized on-premise clouds, whether it be an on-premise VMware stack or an Azure stack as part of their Azure Stack Hub. For our particular purposes, we've actually kept our general infrastructure agnostic for that very reason. And the biggest problem that we face is that while there are several different types of clouds, every program has a different requirement for which cloud to use. And so for our purposes, we essentially went one step ahead and we said, we will use and live on any type of cloud environment that we need to live on, or on-premise cloud environment that we need to exist on, which is good because our hardware cost is significantly nothing, and it really is a software implementation on top of that. And we can leverage our enterprise contracts to essentially get those on-premise clouds, or essentially build out our own cloud if we actually need to.
Thank you for that. Gail, you have your hand up. You've got the floor.
Yes, hi. I love the vision. So I'm wondering, there's some very difficult, complex systems that Northrop Grumman does, being a retired employee. So how are you addressing, or are you planning to address hardware software integration, and especially when there's complex hardware in parallel being developed with the software?
So one of the advantages that our team has is that every one of us has a different engineering discipline background. And we've asked these questions many times, particularly from the perspective of systems engineering all the way to our test engineering. We do intend to actually have an integration between our software and hardware integration and development. And really what that comes down to is leveraging core capabilities such as DevSecOps, where we're going to actually have a team of teams where we can essentially team up and develop both our hardware and our software, and any defects that we find, we can quickly and rapidly move them in. Our architecture is actually a step above that, where it gives the infrastructure for and enables DevSecOps and other capabilities such as that. And so while we would love as a group in our team to push that forward as much as possible, the intent of this is to really be an enabling factor for that, and not so much to force it or to provide to ensure that they actually get to that point. We really want to just make sure the tools are in place, so that way they have that opportunity and they can move in that direction. And then we'll leverage our DevSecOps teams and our software integration teams and hardware integration teams to really pick up that mantle and move forward.
Okay, yeah, thank you. I was kind of interested in whether you're planning to interface with the virtual lab capabilities that are already there.
Yes, I mean, one of our thing here, we have the model repository where we're trying to implement model-based systems engineering. So that's where our digital model is going to rely and kind of aid in the integration process. It gives us a virtual version of it first before we start integrating the hardware, and kind of gives us like what issues we'll see, what defects, and how to best integrate it, like with minimum issues.
Okay, thank you.
Yeah, I don't know, Rick, if you have another question or not. Your hand is still up.
Oh, sorry about that.
Oh, that's okay. Are there any other questions for the team? No? Well, this is that exciting moment. I'd like to give a round of applause for all the teams today. I think that the presentations have been really interesting, wonderful, exciting in different ways, and certainly thought-provoking. They've been working very, very hard, I can assure you that. And it's been a long, tough year. People have been working virtually, but I think the results have been really, quite wonderful. So quick round of a virtual applause to all the team members. Really, and thanks for the people who have come and sat through these and provided the questions. One of the things I want to do moving forward is to allow all the alumni of the AESE program to have access to their materials sort of through the rest of their life, if you will, sort of perpetual subscriptions. And so as we update materials, we'll let you have access to those updates. And for that, right, we are going to be giving you evaluations and feedback. And so some of the feedback that we're going to want to hear will be, what have you learned from this program that's super beneficial to you? What are the things that we should be teaching that we're maybe not teaching, and so on and so forth, so that all of you who are working out there can help gather information and provide feedback to us, so we can continuously, improve our program and the work, that we do for all of you. The other thing I'd like to do is to open up these presentations to all the alumni. So you hopefully will get your final reports done on Sunday. You'll complete the program and you'll be alumni of this program, and you'll be able to attend these presentations for the next years and the next year and the next year and so on. We'd also like to build that community, of alumni, so that you can reach out to other people who have been through this program and sort of form that community on the outside as well. So, don't see this as the end, sort of see this as the beginning of the next phase of all the work that you've been doing. It's not over, because you will be handing in your final reports. I'll be reading the final reports, as will Professor Sorensen and a number of the other professors and lecturers here as well. And we'll be giving you feedback, and I'll want to meet with you and talk to you about that as well. We're also having a smaller, shorter type of a survey that's going to be going out, probably get it on Monday or so. Not exactly sure how we'll get it to you, but it's like a Qualtrics type of a link, and there's, I think, 12 questions or something like that. And so I'm really looking for everybody, to provide feedback on that. So that being said, we've got some of the other lecturers here. I don't know if anyone here wants to say anything to the students before we go, but if so, please step forward or raise a hand, or however you'd like to do that. Hi, Ingolf, you want to say a few things?
Yeah. I just wanted to thank all of the students. Obviously, this is a big milestone after this long year with a lot of work. I certainly enjoyed working together with you, and make you also work on challenging projects and problems that hopefully helped you also, not just for this course, but beyond the course. And I want to thank also all of your sponsors, because they are the ones, if you're not self-sponsoring, who provide opportunity and see the possibility, seeing you grow into a leadership role in your respective companies. And so thanks to your sponsors, thanks for all of you who have contributed today. And I look forward to the next season already. And I can only say it was a spectacular year. You did great. And I really enjoyed being with you this year.
Fantastic. Thank you, Ingolf. Thomas?
You didn't expect me to stay quiet here, John, right?
Of course not.
Well, I would just want to echo the words that Ingolf just said. I really love working with you. I think this is John, you said something, I think, before the break. I'm a US citizen, and I thank you for all you're doing. I am still not a US citizen. I'm working on it. But even as a non-citizen, I think this is absolutely important what you're doing here, and it's wonderful to be in this community. I also would like to as Ingolf said, the industry sponsors, right? This is I would not be interested in working in this program if it wouldn't have something connected to reality, if this would just be an academic exercise. So this is an opportunity, I think, for us as faculty, I hope I speak for all of us, to also learn and see what challenges are out there and what solutions are out there. And finally, I want to echo what John said. The alumni network is something we should think about how to build that and build that stronger, because there's a number of really accomplished people out here that do interesting things. It's great to see some of you back here today. If we can think of ways to make that community stronger, I think we would all win from this. So thank you for having me as part of that community, and hope at some point I will actually meet you in person if I haven't done so already. But I think none of the current students I have seen in person.
Thank you for that, Thomas. Alexander? I can't believe your hand isn't raised.
Everybody already said everything important. I'm really pleased with all the presentations today, and I very much thank you all. And I echo Ingolf's and Thomas's opinion about thanking the sponsors. Also, thank you, John, and Stacy, and Kristen, and everybody who's making the program work. I saw Hal online earlier. I don't think he's here now, but obviously great thanks goes to him. And I wish all of you great luck, and hopefully we'll all see each other somewhere, probably during an alumni event.
Thank you, Alexander. We've got Wendelin online, who's been quiet so far.
Yes. Thank you all for letting me participate in this. I loved listening to your presentations. I loved getting to know the ones of you that I got to know this past year, individually and as teams. And it's been a pleasure. I learn so much from these presentations, both how you think and about the latest technology. I wish I were there in San Diego and I could sit in on every class. Thank you. And John, thanks for doing such a fantastic job facilitating this, all of these hours. We've all been sat here in front of our computers, and it's been interesting. So bravo, John, thanks.
Thank you for that. Really great echoes of thanks, to the administrators, to the people who make all this work, Stacy, thanks so much. Kristen, Yvonne, Amelia was here. I have to say, before I was in academia, I used to think, what is wrong with academics? They're so scattered. Like, why can't they get their acts together? And I realize now that it's because we do so many different things, And so it really takes great administration and help to sort of help pull us all together so that we get a program that fits together as well as this program does. And I'm really taking to heart the work that you all done to make your enterprises better, to make them learning enterprises, to digitize and the work that you're doing. And we have a long way to go in education to match some of the things that you're doing. And so that's part of the challenge, that I'm bringing forth, is how do we do that? And this notion of getting feedback from you each and every year is a part of that process. I mean, traditionally in education, at least higher ed, we sort of, once you stop paying your tuition dollars, everything turns off. And the only time you hear from us is when we want more of your money. I will never come to you for money, but I will come to you to understand how well your education is paying off in ways that we can make this all better, and ways that we can allow this to allow you to continue to grow, because it really is a lifetime, learning experience. And, anytime in the future, if any of you have questions or comments, you can always reach out to me. I'm happy to help, in any way that I can. So it really is, I think, about building that community and working well together. So part of what's lost in some sense being virtual is being together physically in some of those connections. But I'm hopeful that some of you who are at least in the San Diego area can join us physically, for some of the events that we have, so we can sort of continue to build that community. So we're not gone. There's going to be the reports that you're handing in. There's going to be feedback on the reports, and we'll continue the discussion from there. But I have to say, this is the best project cohort that I've ever taught at UCSD. Now, you're the only one I've ever taught, but you're the best one for sure. And it has been a real joy and pleasure working with all of you. And there's always this sort of sadness at the end of the year when you work through a cohort and then you see the cohort sort of step out the door. But we're not going to let you get away. We are going to stay in touch. And I'd love to hear stories on how this course and the things that you've learned in this program have helped you in the future in any ways that we can improve. And so if you have ideas of things that would help us, please send us a line. We'd love to bring that and pull that back in, because our curriculum needs to continue to change because the world is changing rapidly. So again, thank you. It's been a joy, it's a pleasure, and I look forward to continue working with all of you. With that, I think we're about 5 minutes early. So unless there's anybody has any other comments, congratulations to everyone.
you all very much.
Thank you,
Thank
everyone.
you. Congratulations.